Hey everybody, it's Brian and welcome to the course. So, if you already know QObject, you can safely skip this section. This section, we're going to look at QObject, and it's just assumed that you have skipped the beginner's course because you either didn't want to spend time in it, or you already knew C++, or you didn't know it existed. But point being, this is just a review of what QObject is. So if you already know QObject, you can skip this section and move on to the next one. However, if you're still watching, let's dive in and take a look at what QObject actually is. So, according to the documentation, QObject is the base class of all Qt objects. And on the surface, that seems to be very true. However, it's not always the case, especially when you get into templates. It just is, they're simply not QObjects. So, what is a QObject and why do you need it? Well, some major pointers right off the bat. Notice it starts with the letter Q. So anything that starts with the letter Q is part of Qt. That's how you know it's part of Qt. Also, when you're reviewing the documentation, you'll see there's the header that's included, and here's for CMake and here's for QMake. These are your build systems. Then they have pretty much everything that inherits this, and there's a huge list. You can see a lot of stuff. And then you scroll down, you'll see there's some special functions, and then properties, public functions, and so on and so on. You get to this spot here, slots and signals. What are these? Well, let's reverse them. A signal is this object telling the world, hey, I'm going to do something or something's happened. A slot is the exact opposite. It's consuming that signal and saying, okay, you did something, now I want to do something in return. It's actually pretty complex under the hood, and it uses something called mock, which we're going to demonstrate in this video. Now, understand that there's a lot of complexity here. I mean, just looking at some of these things, we see notification, signals, slots, receivers, senders, timing events, timers, and threads. There's a lot to QObject. So, what QObject really brings to the table here at its core is the Qt object model, along with signals and slots, which we just talked about. Now, I love this graphic because it really illustrates what's going on here. We're going to dive into this in other videos in this section, but you have an object that raises or emits some type of signal, and then mock, the meta object compiler, connects these using QObject to a slot. So you have a signal's emitted and a slot consumes it. And you can do that cross-thread. It's actually very, very brilliant. All right, now that we've got a lot of the theory out of the way, I'm going to just minimize that. And these videos, I'm going to start at an intermediate level. So this is probably one of the only videos where you're going to see me actually start Qt Creator. So I'm going to give you a brief overview of Qt Creator really, really quickly. So Qt Creator looks big and scary, and I'm assuming if you're watching this series, you know how to use this, but just in case, let's go through a quick tour. So over the years, not a lot graphically has really changed with Qt Creator. That's what I love about it. It's actually graphically pretty stable. But when you're on this Welcome tab, what I want to point out is the Examples button. A lot of people email me and say, how do I do XYZ? Well, if you just go to Welcome, Examples, and then type it in here, there's usually tons of stuff. So if I say like server, like you want to know how to do a server, guess what? They have all the examples with source code already baked in. It's extremely cool. And if you have multiple versions installed, you can just simply select the version over here. Very, very cool. You also have tutorials and marketplace. Now, I'm just going to say it. I love the tutorial section, but it's not kind of the caliber of what you're watching right now. It's more like tech talks and things like that. You also have edit, which really isn't abundantly helpful when you don't have a project open, debug for debugging, projects, which are your kits. I'll talk about those in a second. And the help system is baked right in. This is phenomenal. I absolutely love the help system. Again, we're just assuming you're at an intermediate level, so that is highly redundant. This is where I'm going to speed things up a little bit here. So in future videos, you're not going to really see me create this, but we're going to go in, we're going to make an application. I'm going to choose a Qt console application. What we're talking about is Qt core. So we're not going to do any user design. This is all core. If you choose widgets, you're going to create a widgets application. A good example of a widgets application is, well, Qt Creator. You're actually looking at it on the screen. It's built with Qt widgets. And then their newer user interface is QML, which is Qt Quick. There's some discrepancy and concern over what is what. Qt Quick is, well, the graphical layer, and QML is the language that makes all of that work. I cover that in a completely different course. But anyways, feel free to dive in and take a look. You can make libraries, other things. I mean, it goes on and on. This is really complex. So application, Qt console, choose, and then I usually follow a very specific naming convention to make it super, super simple to find this out on GitHub. And every single video that has source code will have the GitHub link to it in Udemy. All right. So we're going to say Qt6 Core Intermediate, and this is section 3, video 1. Feel free to use whatever project name you want, or you don't even have to write the code. You can just go out to GitHub and grab it. Create it in whatever folder you want. Now you have your build system. We covered the differences here. You'll see QMake, which is Qt's proprietary build system, QBS, or Qt build system. That's something we don't really cover a whole lot, and then CMake. We're going to use CMake, but feel free to use whatever works for you. Next, you have a translation file. This is if you were going to translate your application using the Qt Linguist tool to other languages. And then kit selection. A lot of people ask, what is a kit? Well, a kit simply tells Qt Creator how to build and run the application. So if you hit manage, you can see here's our auto-detected kit, and that's exactly what it does. It calls different compilers, debuggers, and things of that nature. You can make different kits for different things. You can have desktop, you can have multiple versions of desktop, multiple versions of Qt. So for example, on this machine, I have Qt 6 installed. 9 times out of 10, you're going to want to stick with the auto-detected, but at times you can actually just clone it and then modify it to your needs. When in doubt, leave everything as the default. Spoiler alert, yours may say something different. I'm on a Linux virtual machine. This may say desktop Qt, whatever the version, and then MingGW on Windows 64-bit or Visual Studio or Mac with Clang or whatever. Just hit next. Project management, if you have source control, hit finish. And this is where most of these videos are going to start. You're going to start the video and you'll see Qt Creator already open with some source code ready to go. Now I'm going to just paste in some comments, and this is pretty much the standard way I'll do things. You'll see something like this. What? Well, we're going to cover QObject. Why? Because it's the base class for almost everything. We're also going to review the basics. We've gone over most of them already. And then how? How is going to be the bulk of every single video where we're going to actually work with the code. Now you'll notice over here, you have debug. So we're in debug mode. We could switch to release, minimum size, release with debug info. Most of the time I'm going to be in debug. Release is when you would release this to your end customer or out into production. Then you have the debug button. This would start your project with the debugger enabled, or run. Usually we're just going to run, or we're going to click this little hammer to build. Now, if you click on projects, this is what's a little bit confusing. Draw your attention up here to manage kits. You can see we're just using a kit. So the project will define what kit you have. You can have multiple kits per project, and then you can use this little guy right here to switch between them. The biggest thing I want to draw your attention to is under your kit and run, you see this little checkbox that says run in terminal. We're almost always going to run in terminal. So when we run, and if you press Control R, it'll just run it. It will look like this. You see it's building down here, and then you get this window. Notice that you've got this little cursor blinking. That means the application's still running. That's an event loop. So let's go ahead and close that. Let's uncheck it and run it again. Notice how we don't get that window, but this guy is blinking. This is application output. So our application is still running, and it's running inside of Qt Creator. It's not really inside, it's a separate process, but we're using Qt Creator to interact with that instead of having a terminal open up. How you run it is specifically up to you, and some people that never can get it to run in a terminal, this may be the way to go. When you're done, you can just click stop, and it stops that event loop. You see how it says it crashed, but it really didn't. We just forcibly stopped it. Remember, click projects, and then check or uncheck run in terminal. These videos will almost exclusively run in terminal. That way, when you're running, it'll be very obvious what's going on here. You'll see this big black window. Remember, this cursor blinking means we have an event loop. So let's take a look at that. Let's look at our code here. We have very simple code. It just says include Qt core application. Remember, starts with a Q, therefore it's part of Qt. And we can just simply highlight something and press F1 on the keyboard, and it brings up the documentation. Same documentation in the help system and the same documentation out on the web. I absolutely love that. So you can see it inherits QObject. So this goes right back to our conversation about QObject. So the whole point of QCore application is it provides an event loop, meaning it keeps our application alive. So if other objects are talking to each other via signals and slots, this event loop will keep it running. And then you see return a.exec. This is the actual event loop right here. We would just simply do things here. So it's really cool that we have a QObject, and it's the bulk of our application right now. So we just have our main function, which in C++ is the entry point of the application, and then we are just taking this over by entering an event loop and doing things as we need to. But we want to make our own QObject. So we're going to go over here, right-click, add new. In case you're wondering how I got there, you just right-click the project name, add new. There's a little bit of a bug, so if you're kind of off and you click something, you won't see it, and it's kind of like, where'd it go? Just right-click, add new, right on the project, and you're going to want a C++ class. Notice you could also do just source or just header. We want a full class. Enter a name. I'm just going to say test, and choose the base class, which is QObject. As soon as you do this, two things happen. Include QObject header and add the Q_object macro are both checked. It's imperative that both of these are checked or it will not officially be a QObject. You can absolutely inherit a QObject and not have the macro, but it's not truly a QObject. Very confusing. We're going to cover that in another video. Then you have your header file and your source file. Hit next, finish. And at the time of this recording, Qt Creator does not automatically add this to our cmakelist.txt. So I'm just going to hit no, and then go to where it says executable. And we can just simply type it in. And it tries to help us out with the name. Hit save, and voila, you should see your header and your implementation file. Let's take a look at our object and get rid of that annoying little thing. So we have test.h. And inside we have our include QObject and then the Q_macro, and then we have a spot for signals. What you don't see is you also have slots, but you can actually modify them so they're public, private, or protected. So for example, you could say public slots. And then you would define your slots there. We're going to cover that in another video. I just wanted that to be abundantly clear what's going on there. You don't necessarily need them. That being said, we're going to leave this bare bones for now. I am going to go in here, and let's go ahead and make a deconstructor. And let's go ahead and include QDebug. Let's highlight that, hit F1, and let's see what QDebug does. The QDebug class provides an output stream for debugging information. Notice, however, it does not inherit QObject. It inherits QIO-based device. Interesting. And when you kind of scroll down here, let's just take a look. We've got some static methods. We've got some different things. You don't see signals and slots. So this is not inheriting QObject. But what QDebug does, it allows us to simply output things on the screen. It can do that via a debug, info, warning, critical, or fatal. Just different levels of logging, basically. And you're going to see that demonstrated throughout these videos. Now that we have these in here, we can right-click our deconstructor, refactor, and go add definition in test.cpp. Voila. Now, for future videos, I'm going to just completely whip through that at the speed of light because it's just assumed that you already know it. So if this is going a little too slow for you, don't worry. I'm going to speed things way up. All right, so in our constructor, we're saying constructed, and then deconstructor, we're saying deconstructed, just so we can see that object's life cycle. In our constructor, we are getting another QObject or a pointer to it called parent. So what this does is it creates a parent-child hierarchy or an object tree. The premise being, and again, we're going to cover this in future videos, when the parent is destroyed, all of its children are automatically destroyed as well. So if this little guy existed out on the heap, and its parents destroyed or deleted, it will automatically delete itself. So it really makes memory management super, super easy. All right, let's go ahead and close that, and go back here. And let's just simply observe the life cycle of this object, and then we're going to talk about mock really, really quickly. So I'm going to say void life cycle. Let's go ahead and include this. There we go. And let's just simply say test P. And let's go ahead and do something. There we go. Save, run. And voila. So what we see here is that our object has been constructed and deconstructed. That's part of QDebug. We have our class name, our address, and then whatever we put out there. This is a pretty standard method, and you notice that cursor was still going, so we still had that event loop. QDebug is got QInfo baked right into it here. So if we F1 on that, you can see QInfo calls the message handler with the informational message, so on and so forth. And it just simply, you can do it multiple different ways. Again, assuming you already know that, this is just a simple review. Now, the other thing I wanted to note is the compilation process. When we built, and I'm going to actually just rebuild this whole thing, there's a few things that Qt does. So I'm going to rebuild. All right. See right here, automatic mock in UIC for target. What in the heck is that? You can see here's our test object, our main object, but then notice this guy right here, our project name AutoGen mocks. Mock stands for Meta Object Compiler. So what mock is doing is scanning through all our files saying, oh, this has got the QObject macro. Therefore, it is a QObject, and mock goes in the background and actually does some compilation steps. Just wanted you to be aware of that. Let's go further down the rabbit hole and look at the QObject macro. So what is it? Well, it's just simply a macro. And if you go into our test class from the last example and hover your mouse over it, you're going to see it right there. It looks ugly, and well, it kind of is. We don't really need to worry about it as long as it's in the private section of our QObject class. All of that's done automatically by the wizard, but if you were to hand code this out, you've got to remember to do that, or bad things will happen. Remember, to officially be a QObject, you must inherit QObject and have the QObject macro. So why do we even need this? Well, that's a good question. Why is because it tells mock, the meta object compiler, to convert the class into a true object. So basically, and we're going to demonstrate this, it goes in and adds in signals and slots, or I should say it adds the mock for the signals and slots, and then based off our code, connects or disconnects them and adds meta type information and a whole bunch of other stuff that honestly we didn't want to worry about and we shouldn't have to. So we're going to play around with this. Specifically, we're also going to comment that macro out and see what happens. So out in our directory, you see I do not have a build yet. Let's just right click this and rebuild. Okay, let's see what's going on here. Scroll up, you see a whole lot of compilation starts happening. You can see our compile output. Ooh, what's going on here? Contains macro, but does not include main.mock. Consider. Ninja stop subcommand failed. This is what happens when you do things in the real world. Auto mock error. So main CPP, oh, I see what's going on here. When we look at our source here, main.cpp, contains a QObject macro, meaning it's detecting these guys right here in our comments, but does not include a main mock. So just simply having this in here shows you just how fragile this whole process can be sometimes. Enable skip auto mock for this file. So really what's going on here is as we build, what's going on is this process. Generating mock for UIC for targets, and then it goes through and tries to figure out by scanning each file what has the QObject macro. Interesting. So let's actually, I'm going to cut those out. Let's clear this and let's retry that whole process again just to see if it triggers it. Notice how now everything works just fine. So that's exactly what's going on. And you notice how automatic mock in UIC for our target, and then it generates this guy right here. based off of our test class. So everything worked as expected. And if we simply go in and add that again, even though it's in the comments, that's just kind of funny. Let's go ahead and rebuild just to see. Yep, sure enough, it's starting to really get mad at us. Boo. All right, so much for the real world. So I'm going to just get rid of that little underscore here. But it really proves a good point that just having that in there, even in the comments, Mock's going to scan it, look for it, find it, and then try to do something with it. When we look at our build folder now, you see here is our executable. On Windows, you'll have like a .exe behind it. And then you have your AutoGen. Ooh, what's going on here? Let's go ahead and peek in here and see what's going on. Meta Object Compiler, compilation.cpp. You have your mock predefs. You have some includes and all sorts of other stuff. Some of these may be blank. Some of them are going to have things in it. Mock_test, exactly what I was looking for. This is the mock for our test class. Now, our test class does basically nothing. We just have a constructor and a deconstructor. But when we look at it, let's go ahead and crack this open. You can see meta object code from reading the file test.h. Tells you exactly where it got it from. And it says, warning, all changes to this file will be lost. They mean that this will get overwritten every time you rebuild, so don't play with this directly. But this is what's going on. Mock is going in under the hood, looking at the meta information for our class, and then trying to figure out what it needs to do, putting it into the QObject system, and then connecting any signals and slots. If this looks horribly confusing, it's because it, well, is. But that's the beauty of it. You don't have to worry about it. You can just simply close that and work with QObjects directly. But again, you need this macro for this to officially be a QObject. Now you remember in the main file, just having that in the comments really made Mock mad. So we're going to actually remove it from here and rebuild this and see what happens. Notice how we get a good build. Nothing gets mad at us. Just to prove that, let's clear that and rebuild it again, just to show you. This is something that really trips up people. So we don't have that macro in there, and everything appears to build just fine. And if we go back out here, we still have AutoGen. And let's go ahead and just kind of poke around here. You notice what's missing, though. There's no test mock in here anywhere at all. It's just gone, which means our test file is no longer a true QObject. So when mock runs, signals and slots will not get connected. Let's go ahead and put that back and rebuild that. So if you're ever typing out a class by hand, or if you accidentally uncheck that macro box during the wizard, if signals and slots are not working, 9 times out of 10 it's because this macro is simply missing. Now you see how everything just reworked. And if we go back in here, ta-da! Where is it? Where is it? There it is, test mock. Just to demonstrate one more time, let's go ahead and get rid of this. Save, rebuild. All right, just simply gone. Nowhere to be found. Major takeaway here is what you're going to want to do is make sure, triple check, you always have this macro in the private section for any QObject class you're making, or you're going to have a bad time. And when it fails silently, meaning you can inherit QObject, but not actually be a QObject because you don't have this macro. This video, we're going to deep dive into signals and slots. So our project here is very simple. We just have our test class, very stripped down version. It's just got a constructor and a deconstructor. And we have a main file, which is using that. So what signals and slots? Why? It's easy communication between QObjects. And you notice I have QObjects highlighted. This only works between two QObjects. And how? Well, we're going to make two QObjects. We're going to make them talk to each other. So let's go ahead and look at this real quick. I am going to do a little bit of copy and pasting just to save time. We know this is a true QObject because it's inheriting QObject, and we have the QObject macro in the private section. Remember, we covered this in the previous video where we said this macro's got to be here for mock to really see it and try to connect it to other objects. Without that, it's not truly a QObject. So let's go ahead and grab some code. So signals, we are going to emit a signal out into the real world. It's always public, always defined, never implemented. You'll be surprised how many people will try to implement this. This is just simply a prototype. So if you go here, right click, go to refractory, you'll notice how it says rename, but it doesn't have the ability to add. So the IDE is smart enough to realize you should not do that. Now we're going to do some slots. It's not okay just to say slots. You need to actually give it public, private, or protected. So I'm going to say public. And I'm just assuming from C++ class, you know what public, private, and protected really are. And all right, so a slot can be public, private, or protected, always defined and implemented, should match the signal. What I mean by that is you have your prototype, a signal, and the slot should match that. You notice how they are both the same. QString, QString. Now we should implement this slot. So let's right click it, refractor, and we can either inside, outside, or in our implementation file. I almost always do it in the implementation file. And then let's go ahead and we are going to just paste in some code. So we're going to QInfo from and then sender. Sender is a special function inside a QObject that says, hey, who is calling this slot? You notice how if you look at this, a slot just exists. It looks like a function, and you can actually call it like a function, but you can also connect it to a signal. So we need to know what object is calling this. That's our special sender function. It's just going to return a pointer to a QObject. See, ta-da, returns a pointer to the object that sent the signal. And then there's all sorts of little gotchas and things like that. For example, if called in a slot activated by a signal, otherwise returns null pointer. Meaning you may actually in the real world see things where you cannot get a pointer to the object, meaning the object was destroyed or it was called like a function, something like that. And then we're just going to print out our whatever QString. I'm going to go ahead, go in here one more time, and we're going to make a little itty bitty, if I don't collapse that, function called testing. And then right click refractor. You don't actually have to right click it. You could just type it out if you really, really wanted to. And I'm going to say QString. And let's call this noise. Wake up. This is going to be like some alarm clock kind of noise, some loud, annoying buzzing thing. I'm sure you hear that all the time. Now, what we're going to do is we're going to emit a signal. Think of this like popping a flare gun out in the wilderness. This big, bright flare goes out into the wild. So we're going to emit our signal. Now, you may notice, I'm just going to click off, it has a special icon. It's got like these little Wi-Fi bars over it. So we've got an object that's emitting or signaling out into the world. And then we're just going to give it our variable. So what that's doing is emit is going out into Qt Core and saying, hey, we have this signal called alarm, and we're going to emit it. And anything connected to it will automatically have its slot called, which is why these two have to line up. They have to be the same prototype. All right. Pretty cool. Now, let's look at Wake really, really quick. You notice how it's got this little special icon, and I'm going to just kind of click off and we're going to look at it. It's got these little indents like you would plug like an electrical outlet into it. That's how you know it's a slot. We're going to plug into that, where these others do not. That's how you would differentiate between just a normal function and a slot. But the caveat being you can actually call a slot like a normal function. You could actually say something like that. So there are programs out there where you will see them using signals and slots and just calling them like normal functions. It's perfectly fine to do both. All right, now from here, let's go into our main. And what I like to do is give it a good build just to make sure we didn't goof anything up. I'm not really good at going slow, and that's when I tend to make a lot of mistakes. So as I speed up on these videos, I'll make a lot less mistakes as I say that. So we're going to say notifications. We're just going to make a simple function. Go down here. Go ahead and call that. We are going to make two Q objects. So we're going to say test mom and test child. Now, I'm sure if you're a parent, you've been in this situation where you've got to get your child out of bed and it's rather annoying. But what I want to do for clarification here is I want to set the object name. You don't actually have to do this. I'm just doing this so when we're looking at this in the console, we can tell which one is which. So let's go ahead and do something just for demonstration. Say something like Q debug. And we're going to send mom out to QDebug land and child. Ooh, what's going on here? All right, so it cannot figure out what to do here. So what we need to do is actually, it's looking for the address of it. It's simply because we have it out on the stack instead of the heap. So we have to give it the address of. Let's run this. And doing set object name will actually put the name in here. You notice how when they're constructed, we haven't set the name, so we don't know which one of these is which. Logically, we can look at the code and say mom was constructed first, but we don't really know if that's mom or child. Setting the object name will put it right in there in the QDebug or QInfo, whichever one you're going to use. And then you can see during the deconstructor, we can tell which one is which. All right, let's go ahead and get rid of that. Now what we're going to do is we're going to connect these two objects together. It's very important that you connect them before you try to emit a signal, because the slot will simply never get called. So we're going to say Q object, and we're going to connect. And notice how there's multiple ways to do that, 8 of them exactly at the time of this recording. And each one has its own little use case, which regardless of which one you use, it's actually very simple. We need the sender, in this case, mom. And we're going to say we want the function. In this case, it's going to be the alarm. And then we're going to say we want the receiver, in this case, child. And then we want the slot, which is also just the function. So I'm going to say test, and let's go ahead and say wake. Now, some versions of Qt Creator will annoyingly put in these parentheses. If they do, just get rid of them. Super annoying that they did that in older versions. We've successfully connected that. Now, there's an extra little step I want you to be aware of. Automatically, it's doing this for you, but there is a connection type. So you can say connection type, and then you have like auto, blocking queue, direct connect. We're going to cover all these, but auto is the default. You would use Qt connection if you're working with threads, and then the other ones kind of have their specific use case. It doesn't really matter which one you do at this stage, but just know that auto connection is the default. That's what's happening. And you could, of course, shorten that to this. Now I'm going to plop in some notes real quick, just so you don't have to watch me horribly misspell that. Now we're going to start a chain of events. What we're going to do is we're going to emit. So I'm going to say mom.testing. Now I want to back up here. You notice how each one of these has different icons. So for example, testing is a function where delete later has that little plug. That's right, that's a slot. We could also go all the way down to wake, and just call it directly like a function. Just very important that you understand that you can call a slot like a function. But in this case, what we're going to do is we're going to say mom testing. Now, inside of testing, we highlight that and follow symbol under cursor. We are emitting the alarm. And remember, in our main, we've connected our alarm from mom to child wake. So we're basically, the mom's going to go in and scream, wake up at the child. So now you have your signal in your slot. As long as we've got that in there, we're good to go. Let's go ahead, save, run, and watch this in action here. So sure enough, we've got our constructed, and then we have emitted, and from test mom, wake up. That's exactly what's going on here, and then they're deconstructed. So we got mom constructed, child constructed. We've emitted our signal, and the slot kicks up in the child saying, from mom, wake up. Very fundamental that you understand signals and slots and just how simple they are. And then we just have both of those deconstructed. So what's the difference between using signals and slots and just calling it directly? Well, if you call it directly, and let's actually do that. Just going to say now, you ever just yell at your kids, get out of bed right now. Let's run this, see what happens. You can see from QObject00, meaning there was no sender, but it still works. We can call it directly like a function, but we lose that interaction between objects. Think of it this way. If you want to do like a producer-consumer kind of scenario or a mother-child kind of scenario, like we kind of illustrated here, you lose that if you just call it directly. And that's why signals and slots really exist. We want event-driven programming. Additionally, if we go in here and we play around with this, and let's just get rid of this macro. It's making me kind of nervous doing this. I'm not going to lie. It's making me really nervous to see what's going to happen here. Let's rebuild. I've had sporadic issues with it. Yeah, see. Static assertion failed. No QObject in class with signal. So now it knows we're trying to use signals and slots, but we don't have that macro. I did have an older version of Qt where this actually built and ran, but then ran incorrectly. So anyways, that's what happens if you remove that macro. Put the macro back in, save. Let's go ahead and rebuild. And you see it all magically come back to life. And it runs just as you would expect. All right, the last fundamental concept I want to drive home here in QObject land is they cannot be copied. That's right, simply can't do it. The memory address is the object's identity. That's the reason why. And it's very simple, very fundamental when you break it down into terms of signals and slots. Think about it. You have an object, you've got some signals and slots, and then you make a copy of that object, and something emits a signal that you're connected to. Which object triggers the slot? This could be bad. I mean, if you have an object that's, say, controlling the brakes of the car, you only want that to hit the brakes one time, not twice or 50 or 1,000 times. So you got to be a little bit careful. So we're going to demonstrate this using simple functions. So let's go ahead and play around here. I'm just going to say QObject, and let's call this person. We're going to say person.set object name. You 100% don't need to do this. I just do it just so when we are using QDebug, it's very easy to see what's going on here. Now we're going to test a pointer, test an address, and then test a copy. So let's go ahead and test a pointer first. So I'm going to say void test pointer. And I'm just going to grab that. And we're going to say QObject obj. I'm going to say QInfo. I always have a tendency to type in those parentheses. It kind of drives me nuts sometimes. All right, very, very simple. So we're just going to test that pointer. Let's grab that. And we're going to say address of person. C++ doesn't care. As long as it gets the address, it will do its magic. Let's go ahead and run this. And voila, it just works. So there's our object at this memory address. Notice it's always in there. Even if we don't set the name, the address will be in there. And it's because as far as Qt goes, the address defines that object as being unique. Let's go ahead and close this. And everything's going to work just fine. We're just going to copy and paste this. I'm going to speed through this because I know it's going to work just fine. Maybe, if I can type it out correctly. And one thing we got to do here is we've got to modify that, because QDebug, or more appropriately QInfo in this case, is really looking for an address of the object. So now we can just simply test the address. Whoops, why did I put test in there? Person, I told you I was going to screw things up in these courses. Here we go. So we're going to test that address, and it should run just fine. Now comes the interesting bit. We are going to completely break everything. But you see people doing this all the time, and I get tons of emails going, "Dear sir, why won't this work?" And it's because Qt objects cannot be copied, period. So we're going to just simply say, boop, we want to make a copy of that. Now, you notice how if we do this, it's still griping, complaining because it wants the address. And you'll get to this point and you think, it's going to work, right? Let's go ahead and go test copy. Okay, let's just go ahead and take our person, plug him right in there. And notice how it's called to delete a constructor. This is where people get really confused. They're doing copy, but it says call to delete a constructor of QObject. What's going on here? Well, let's just throw caution to the wind and try to build this, see what happens here. Nope, just will not even go. So use of deleted function, and then it's got a constructor. So what's going on here is they've deleted the copy constructor and a whole bunch of other things. And it says QObject has been explicitly marked as deleted here. And if you click on something, you see you're in QObject H, you're at 427, and then there's this little macro, QDisable copy. That's exactly what's going on. They're using this guy to say, hey, you cannot copy this object, and they forbid you from doing it by simply deleting the copy constructors. It really is that simple, but it actually safeguards you from creating a whole host of headaches in the future. The biggest takeaway here is the Q_disable copy will keep you from making a copy of the object. So whenever you're working with Q objects, this is a big no-no. You simply cannot make a copy. It won't even let you try to do it. So when in doubt, use the address of or use the pointer. Let's quickly review memory. If you already understand computer memory and especially C++ and how to deal with memory, you can safely skip this video. This is a refresher in case somebody's coming from newbie land and they need a quick review. So before you, I have a big blue area and it simply says this is memory. It's just a representation of the computer's memory. When you run a process or an application, it is created and runs in memory. It's in your computer's RAM. And those processes create variables. Those variables also live, you guessed it, in memory. Now, we're going to start talking about stack versus heap. The stack is a continuous region of memory. It almost appears like it's inside the process, inside the program. It appears that way because, well, it allocates and deallocates memory automatically, and it's considered a safe area. It's safe because memory is deallocated automatically. But the stack is limited in space, and that's determined by the operating system. Here's an example of a variable on the stack. You've seen this before where you have your main function, and then you have some variables. Those variables all live on the stack. They are allocated and deallocated automatically. We simply don't have to worry about the memory management. Now, when we look at memory outside of the stack, that's called the heap, also called the free store. That's the rest of the memory in the system. Programmers create objects on the heap, but we must manage them. Typically, we do this through a pointer, which means we have a variable that lives on the stack that points to a region of memory on the heap. We have to allocate that memory using the new keyword and deallocate it using delete. This is called memory management. We have to do this manually. When we talk about stack versus heap, let's look at the heap. Programmers must manage these objects. And this is a really good example of what I'm talking about here. In our main function, we allocate that by creating a variable on the stack that points to a region of memory on the heap. We have a pointer to cat on the heap. Seems rather confusing, but this is a really simplified representation of what's going on here. Something on the stack allows us to point to something on the heap. As you might have guessed, managing memory is, well, complicated and error-prone. We can create all sorts of problems. For example, a memory leak. We see a well-behaved function. Here, we're allocating memory and we remember to deallocate it. That works as expected. However, if we forget to deallocate that memory, well, guess what? It's removed from the stack, but it still exists out on the heap, consuming available memory in the system. If that function is repeated over time, it's going to consume more and more and more memory. That's bad, and we could have dire consequences, including system stability. This actually used to crash older operating systems. To make things worse, well, some operating systems don't release that memory even after the application closes. So once the process stops running, that memory is still being consumed. You guessed it, this can cause a lot of headaches. Let's talk about dangling pointers. Now, this has a really funny name, and I'm going to overly simplify this. I mean, this is both an art and a science. Imagine, if you will, you have this function where you allocate and deallocate memory. Seems very simple, and this is exactly a well-behaved program. You create it, you destroy it. It's that simple, and everything should work. But notice what happens. The pointer that's pointing to the heap is still sitting on the stack, and we're waiting for the stack to get rid of it. That can cause all kinds of problems. For example, let's say we allocate an object and then deallocate it, but then try to access the object which no longer exists. Yes, this is the cause of a lot of major software applications to just completely crash. You ever been working in an application and it pops up and says, boop, unknown error? This is usually what's happening under the hood. Dangling pointers are very dangerous, and they're also very hard to catch. Introducing smart pointers. They are exactly what they are named. They're pointers, but they're smart. So be smart, use smart pointers. Okay, admittedly, that was a little bit cheesy, but point being, these things are incredibly cool. It's simply a pointer that knows when it should automatically delete, meaning it does it for you. You don't have to manually manage the memory. This is extremely cool. An example would be this. You create a pointer, and when the stack deletes it, it deletes the memory out on the heap. Very, very cool. Unfortunately, it also does have a little bit of complexity added to it. So for example, we're using a shared pointer using a cat class and a variable on the stack called kitty, which points to some object out on the heap, a new cat class. But you notice there's no need to manually delete it because it will automatically delete itself. Yes, this does add a little bit of complexity to the code. However, you don't have to worry about a dreaded memory leak. The main challenges with smart pointers is simply picking the right one. There's a unique pointer. This is in the standard library, and as the name would suggest, only one can exist. A shared pointer, again, standard library, reference counting, many copies can be made. Weak pointer, again, standard library, is a weak reference to a pointer, meaning it doesn't actually own the pointer, it's just going to use it. And then, of course, auto pointer, which has been replaced by unique pointer. So you'll still see auto pointer out in the wild, but this is something I really wanted to touch on. Smart pointers, even though they're smart, are not perfect. Auto pointer is actually very evil and you shouldn't use it. Instead, use unique pointer. Now, there are tons of others. People are constantly creating them, and Qt has created their own, which we're going to cover in this course. You're going to see primarily Qt smart pointers, and I will really only use smart pointers when we're talking about smart pointers. I may sprinkle them throughout the course, but I want to keep the code as simple as possible just for the sake of learning. But whenever you see a pointer in your program, consider using a smart pointer. Let's talk about memory management. Specifically, we're going to talk about the QObject class parent-child relationship. So when we look at this, QObject, it just says it's the base class, and we go down to more, and it says QObjects organize themselves into object trees. Interesting. And when you go in here, it has kind of a lengthy explanation and some code examples, but doesn't really give you like a graphical, hey, this is what's going on. So if we look at it here, we've got a QObject. And in the constructor of QObject, let's go back here. All right. We see in the constructor, we have a parent. It's automatically set to null pointer. Now, if we have a parent at either the construction of the object or we later set the parent, it forms an object tree. So for example, let's say this is an existing object. We're just going to add another one. And it forms this nice little tree. And objects can have other objects, and you can just take this out to like some extreme and just make this gigantic, larger than life kind of object tree here. And this is exactly what's going on. Now, the thing is, let's say these are all pointers. That's right, pointers, meaning you have to manually manage that memory. Well, that's not the case with Qt. If you were to delete an object, the object and all of its children will also automatically be deleted. So for example, if you deleted this guy right here, everything in this object tree is going to be deleted. However, if you deleted this one, just these two will be deleted. It's actually very elegant and very easy to work with. It makes memory management just a hindsight. You don't have to mess with it anymore. Just simply set a parent. Now let's go ahead and create a QObject. We've done this before, but just for review, let's go ahead and add new. We're going to make a class, and I'm going to whip through this because we have done it before. We're going to call this test. It's going to be a base class of QObject. Make sure that QObject and Q_object are both checked. So this is the header and this is the macro. Remember, the macro is what really determines if Mock's going to pick it up. Hit next and finish. At the time of this recording, of course, it's not going to automatically add it. So we've got to add it ourselves. So I'm going to say test.h and test.cpp. Hit save, and it should add them into our project. We've got our header, and we've got our implementation file. From there, we can switch directly into the header, and I'm going to include Qdebug. And I'm going to do a deconstructor. Right-click, refactor, add definition. And now that we know how to do this, I'm probably just going to skip through that in the future. But what I'm going to do now is I'm going to modify the constructor. Remember, one of the real challenges here was if we create a QObject and we don't have a name, it just gives us the memory address, right? So we're going to go in here, and I want to modify this guy. You notice how when I've modified it, this little light bulb here appears. So I'm going to click that. You can either click it or Alt return, and it will automatically update it for you. Most of the time, this works just fine. Now you notice I've made a boo-boo. It says missing default argument. Okay, that's very, very simple to fix. So we can just simply go in here and change it. And we can switch between header and source. From here, I'm just going to copy and paste some code just for the sake of time. We're simply going to set the object name to whatever we supplied in the constructor and then say constructed this. And then in our deconstructor, we're just going to say we deconstructed the object. We're going to use this test class to build an object tree and see when things are constructed and deconstructed. Now that our test object is created, let's go ahead and use it. So I'm going to go ahead and just include it, and then I'm going to make a function, and we're going to build an object tree here. So say test pointer make tree. Horrible typing included at no extra charge. Let's go ahead and see what it takes to do this. So first thing I'm going to do is say test root equals new, and immediately should stop and pause and go, okay, we're using the new keyword. We're manually creating something in memory, meaning there are bad things that could happen. And let's call the null pointer along with a name of root, not layout, root. Misspellings abound. You ever get that where your keyboard's just like slightly off center and it just messes up your whole day? Got that going on right now. And then we're just going to simply return this. So we have a Q object. It has no children in it. It's just simply a pointer. We're going to use that to add children to it. And this code is going to be ugly looking, but it's actually very, very simple. I'm going to say for int p equals 0. P is, I'm just kind of making up numbers in real time. We can, if we wanted to, grab this guy here, do the magic copy and paste. Let's call this POBJ, short for parent object, null pointer, and let's just misleadingly call this parent. Technically, the root is also a parent. It is actually the root or the parent of all of them. But what we're going to do is we're going to get this root, and we're going to make the root the parent of the parents. So it's the root object. That's a little confusing. Think of it this way. We have a root object. Anything underneath it, when we delete this, will automatically be deleted. We also have these P objects or parent objects, and these are going to have children underneath them. So if we delete one of these, all its children will automatically get deleted as well. All right, now that we've got this guy, let's go ahead and say for int c equals, and I'm just going to say 0. And I don't want to do 5, let's do 3, just so it really stands out on the screen. Now, from here, we can, if we wanted to, through the magic of copy and paste, just grab this, paste. Let's call this C object, short for child object, equals, and let's go ahead and do a P object for the parent. And let's call this child. Now, because we're building a tree, we want some way of differentiating which ones are which. So what I'm going to do here is I'm going to change the names to string, number, and then whatever P is, and then we're going to do the same thing with C. That way we can see what it is. But I also want to know, hey, what is this a child of? So I'm going to say a child of this guy right here. So it's going to say the child of whatever the parent, and then the actual child number. So we get just kind of like this ordered number thing. All right, now let's go ahead and do one more, and we can, if we wanted to, just copy this whole thing. I told you this was going to be ugly looking, but you will see code like this out in the wild, and it will drive you absolutely bonkers. So let's call this a sub object, which is going to be a child of this child object, and let's call this sub. And this is of the parent, of the child, and let's go ahead and do one more. Yes, we got some spaghetti code going on here. We're going to add in S. So it's going to say parent, child, and then sub, and we got that number so we know what level we're actually at. Now you may have noticed this is highlighted and it's saying unused entry warning. This is going to actually issue a warning if we try to compile. So to get around that, I mean, a warning is just a warning. It's not going to break anything. We can use the Q unused. Let's go ahead and do that, which basically does exactly what it explains right on the screen, which is it's just simply unused, but it's getting rid of that warning so we don't have to worry about it. Let's go ahead and give it a good build just to make sure I didn't goof anything up. All right, once we got a good build, we can continue on. Now that we've got that big, ugly make tree, let's go ahead and print it out. So I'm just going to simply say void print tree, and we're going to take a pointer. Let's call this, let's call it root. Why not? And then let's define some sort of level, and the default's going to be 0. The level is just going to be what level of the tree we're actually in. So as it may already allude to, we're going to take a root object and kind of go through all the children of that object. And we want to know what level we're actually at. So the first thing we need to do is just do a little defensive programming and say, hey, does this thing even have children? So I'm going to say root dot children dot length equals 0. Then let's go ahead and hit the eject button. So if there's no children, we're going to say, nope, we can't go forward. Let's just get right out of here. Now I want some sort of a lead here because we're going to print this out in the console and it's going to be just a hot mess if we just start printing raw data. So I'm going to format this a little bit. So I'm going to say qstring lead. And let's just make our lead character that little guy. And then we want to say lead dot fill with this little guy, whatever the level is. And we want to multiply that by, I'm just guessing, pick it by 5. That way it's going to put 5 of those dashes out there based off whatever level we got, so you can actually see the tree like expanding as we're going through it. It looks a little confusing, but it should be pretty self-explanatory when you actually see it being printed out. I'm going to say for each, and I want to say Q object, and we're working with pointers here, so we want to say obj in our root dot children. So what this does is it gives us back a Q object list, which is really just a list of pointers to Q objects. It's a little complex, but I think you get what we're doing here. So we're just going to go through a for each on each one of those, and I'm going to say test child equals, and what we need to do now is actually cast this object. I did cover this in the beginner's course, but we're going to use what's called QObjectCast. And what QObjectCast does is it's a special cast built into Qt that works really, really great with QObjects. So I'm going to use our test, and we need to give it a pointer. Very finicky about what specific type. We're just going to cast that. So we're taking our pointer to a Q object and casting it into a test here. Now we should, in the real world, make sure that this actually gave us back a valid pointer. So we could say something like if not child, and let's go ahead and return. You could do something like that. I already know that these are all going to work, but let's just leave it in there. Now from here, let's go ahead and say print tree, and we want to do the child with the level +1. So really all we're doing is we're going through each object, grabbing it, converting it, and then going through its children. Now that we've got this little guy, let's go ahead and print it out on the screen. So I'm going to simply say QInfo lead with child. So that's going to print out our Q string that's going to have a number of dashes with the actual object behind it. All right, moment of truth here. Let's see this thing in action. So let's go down to our main here. If we want some screen real estate, we can simply collapse these functions down. And let's go ahead and say we want a pointer, test. Let's call this tree. You can call it whatever you want, doesn't really matter. And we're going to call our make tree function, which of course returns that entire object tree. Let's go ahead and print that tree out. And let's go ahead and say we're at level 1. And then when we're done, we're going to go ahead and delete that object. So we're going to delete the entire tree. If you're playing around with the code, you can, feel free to delete just one object and watch just its children go. But I'm going to wipe that entire tree out. So let's save, run, and let's see this thing in action. All right, we get a whole ton of deconstructed. Let's go ahead and scroll all the way back up here. Yes, that is a large object tree that we're working with here. So we've got our root, and then we've got parent, and then child at 0, 0, sub at 0, 0, 0, and then sub at 0, 0, 1, and then so on and so on. And you can see the numbers building up. And then after we scroll down all our constructed, we have our actual object tree that we constructed here. So we've got parent at 0 with the child, sub-objects, child sub-objects, so on and so on, and then parent at 1, child sub-objects, so on and so on. You can see this nice tree structure that we've created. And then, of course, when we delete our root, everything underneath it is automatically deleted for us. We don't have anything out there hanging out in memory. It's just very elegant and very simple. Now that we understand that QObjects can form an object tree or a parent-child relationship, let's look at a simple example of why you would want to do that. And what I mean by that is, well, we've already seen it in terms of memory management, but you can also use the object tree to form object relationships. So for example, we can say QObject, call this parent. Notice this is just going to live on the stack. We're not making a pointer, so its memory is automatically going to be managed for us. I'm going to go ahead and set the object name appropriately to parent. Now let's go ahead and just, through the magic of copy and paste, grab this, paste it here. Let's call this child. And let's go ahead and set the name to child. Notice we have two distinctly different objects. They are completely oblivious to each other. But if we wanted to pass, say, a single object along with that entire object tree, it's actually very simple. What we could do is something like this. Child dot set parent. And that just simply takes a pointer to the parent. It's really that simple. Now, a lot of people, myself included, when I was first new to Qt, would do something like this. They go parent dot add child, and you notice it's just simply not there. Or insert child, it's just not there. You actually have to do it on the child object. So you say child dot set parent, and then give it an address of the actual parent or a pointer. Once you do that, it now becomes part of that object tree. Now that we have the child, let's say we want to get the parent. Very simple. You just say child dot parent. Go ahead, save and run and see what that looks like. So the child's parent is, of course, our parent object. That is extremely easy to make some sort of object relationship. And we can also do something like this. When we run this, you're going to notice something happen. It is a QList. So it's simply a container or a QList of, you guessed it, QObjects. This is extremely valuable because now we have a list that we can just add over and over and over and do whatever we want to do with. Now, that being said, when we look at the actual function, it's a const, so we can't actually directly modify that. You have to take the children objects and do the set parent. You can't just say parent.children.add or .insert. Notice how it's just not there. It's not going to let you do it. Now, from here, you can also do a for each. We've done this in the previous video, but I just want to demonstrate it once again, how easy it is. It's really that simple. Now we can just print it out. So the major takeaway from this video is setting a parent-child relationship actually goes a step deeper than memory management. You can now form relationships between objects. Note this does not automatically connect signals and slots. It just says these objects are related into an object tree, and then we can work with them in any manner that we want. Now, I did say in previous videos, you can definitely feel free to use the standard library smart pointers. We're going to cover the Qt smart pointers. Specifically, this video is going to cover the QScope pointer. And it does exactly what it says it does. When it goes out of scope, the pointer is automatically deleted. For this, we simply have a test class that's going to monitor the life cycle of this object. We have a constructor, a deconstructor, and we can set the name in the constructor if we so choose. Probably going to reuse this class over and over again. Now, because we're playing around with scope, let's go ahead and make a scope. So I'm going to make a little function here. Let's go ahead and make a QScope pointer. And this is a template class, so we need to tell it what we're going to be working with here. And let's call this SP. All right, do you notice what we didn't do? We're not following the constructor. We're leaving it as a null pointer and the name is blank. So let's just say after the fact, we want to come in here and we want to modify that underlying pointer. Well, there's two ways we can do this. We can either say sp.data, and that takes us directly to that pointer. And then we can do something like set object name, or you guessed it, as you're typing, it's smart enough to know what is the scope pointer and what goes to the underlying pointer. So you can just access it directly. That is super cool. Absolutely love that, because now you don't have to jump through different hoops and figure out what's what and what goes where. It'll just do it for you. And it's smart enough to know when it's a pointer. Now that we've got that, we can do some really cool things. So for example, I can just say QInfo. Let's go ahead and take a look at the actual scope pointer. And then through the magic of copy and paste, let's grab this and let's say bang and bang, and we're going to say pointer data. Now this is the actual pointer, this guy right here. Now let's go ahead and get that object name, just to show that we can interact with that object directly. Let's go ahead and call this. And let's run it. Notice what's happening. Constructed, deconstructed. We never actually called delete. So what's going on here is we're constructing it, and then at the end of this function, this, the scope pointer, is being destroyed off the stack automatically. And as it's being destroyed, it is then going ahead and deleting the object that it's pointing to. That is extremely cool. The other Qt smart pointer I want to talk about here is QSharedPointer. And the name is actually pretty self-explanatory. It's a pointer that you're going to share. So let's take a look at a standard use case here. All right, so we got QSharedPointer. This is a template class. We need to give it the class we're going to work with here. And And we're going to say get object. Go ahead and give it a name. Notice what we're doing here. We're returning a QShared pointer, not an actual pointer. So we're already taking ownership of this object. Now, the object itself is the test class we used in the last video, which of course just has a constructor, a deconstructor, and we can set the name of the constructor if we want. So what we're going to do now is, you guessed it, we're just going to grab this guy. Notice it has virtually the same API as QScope pointer. And we can even do the same thing. We can say like sp.set object name, and then name it if we wanted to. Could have also done that in the constructor if we felt like it, based off the way we designed the class. But I'm just demonstrating that we can access that pointer directly. And you, of course, can do other things here. This is where you would set up your object before you actually return it from the function. Notice what's happening, though. We've created a pointer. Now we're outside of our scope, meaning something else has to have ownership of that pointer. Oh boy. Let's go ahead and play around with this a little bit. So what we're going to do here is we're going to grab this. Just going to say do work. This is how you would pass a shared pointer from one function to another. It's really that simple. Now that we've got this, what's happening is the ownership of that pointer is being transferred. So what we have now is reference counting. That's actually pretty important that you understand that concept. This is a reference counting smart pointer, meaning once that reference count hits 0, it's going to delete it altogether. All right, so in our do work, we're just going to do something, and I'm just going to copy and paste some garbage code here. So we're using a copy of the shared pointer, or a reference is added to it. We're going to work, do a shared pointer, and just print it out, and then the actual object on the data. We could do whatever we want. It's really not super hard. Now, one thing I want to note here is, what is the difference between actually accessing the data, which is a pointer to the object, or doing something like this? Absolutely nothing. You're still working with the same pointer under the hood. That's why I had this little line here, just to kind of point that out, because I've had people in previous classes ask what's the difference. There's virtually no difference. It's just really that straightforward. Now let's go ahead and kind of bring all this together and work with this. I'm going to make a simple test function. Notice what we're doing, though. We're jumping from scope to scope to scope. So we're actually sharing this. That's why it's a shared pointer. And then from here, I'm going to just simply say, hey, we're going to do something. In this case, we're going to get the object, and we're going to say, let's go ahead and grab this guy. I'm just showing you how easy it is, just copy and paste code. Sometimes if you get super lazy, you just really don't feel like doing it. Or you can type it out. I'm going to say get object, and let's go ahead and call this my object. So now we have a shared pointer. We've taken ownership of that pointer. Now, when I say we, we're actually letting the smart pointer do all the work for us, but just understand there's an implicit ownership here. We are now owning that memory. All right, from here, what we can do is just gonna grab some code, do some sort of work with it, whatever it is. And then we can say do work, and we can just pass that over there. We don't have to play around with address of or pointers or anything like that. We can just say, here, copy this, and it's going to do what it needs to do. Now, once the work is done, and the reference count is 0, that's when something magical is going to happen. It's going to automatically delete it. Let's go ahead and test this out. So I'm going to grab this. Save and run. Let's see what this looks like. All right, you notice right off the bat, deconstructed. So it's automatic memory management. We don't have to worry about it. So we're getting the object, it's constructed, and then we're just passing that thing around, almost like a bowl of popcorn at a family movie night where you're just passing around with your family. Really what you need to understand is this is using an internal reference count, and once that count hits 0, it's going to automatically delete itself. So this video is going to cover sharing a smart pointer among multiple objects. Why? Because, well, we want to use smart pointers, but we want to be able to share them. We're going to use a cat and toy analogy. So we're going to have multiple cats and a single toy. Note, we may not use smart pointers often throughout this course because they do add a little bit of code complexity, and I want the lessons to be very clear on what we're trying to do. So we're going to use a Q shared pointer. We've got two classes, a cat and a toy, and we're going to include vector from the standard library, and we have a test function we're going to play around with. Now, our toy is very, very similar to the test class we've been using, where it's just simply showing the life cycle of the object. So we have constructed and deconstructed. The cat is also very similar, where we just have constructed and deconstructed, but we're going to add a little bit to it here. So the first thing we're going to do is we are going to include Q shared pointer and toy.h. So each cat is going to get a chance to play with their favorite toy. All right, let's go ahead and add in void play. And inside of here, we're going to say Q shared pointer. And we can, if we want to make life super, super simple, just grab this, go down here. Now, it doesn't really matter if you want to put a private variable up here in the private section or go down here and add it. I often do it down here in lessons just to be abundantly clear what I'm doing. I'm making private variables. And I typically adopt this naming strategy where I put a m underscore so we know it's a member variable. So m underscore toy. Ta-da, there we go. Now I'm going to right click, refactor, add definition. And then inside of here, what I want to do is actually be able to maintain that reference. Because remember, when we use a Q shared pointer, if that reference count hits 0, boom, it's going to automatically delete it. So I'm going to kind of pass the torch or pass the reference here. So I'm going to say mtoy.swap. And we're going to swap that with our toy. So we're really just saying we want to be able to maintain that reference count. And then from there, I'm going to just copy and paste something. So this cat is currently playing with whatever pointer we got. Very simple, very straightforward. Just wanted you to understand why we're swapping. Swaps this shared pointer instance with the other. The function is very fast and never fails. Keywords never fails. So really it just changes from one pointer to another. All right, now that we have that out of the way, let's go ahead and save and jump back down into our main file here. What I want to do now is, well, let's create some chaos, or actually more appropriately, cats. So I'm going to say int max equal 5. And we'll say Q shared pointer. Let's go ahead and create our toy first, because cats need toys, right? So we're going to say toy, new toy. Notice what we're doing here. We're creating a pointer. We're shoving it inside of a Q shared pointer. So now we are managing that automatically. Now what I want to do is I want to use vector. Why? Because why not? I'm just showing you that you can mix and match the standard library with Qt code. So I'm say std vector. And I'm assuming a lot of you are coming into this wondering, how do you mix and match? It's actually very simple. So I'm going to say Q shared pointer. And we want to say cats. So we're just making a vector of a maximum number of cats. That kind of goes against my personal beliefs. I don't believe there should be a maximum number of cats. But anyways, let's go ahead and just continue on. In case you don't know, I absolutely love cats. I don't know why. I love dogs too. Don't get me wrong, but cats are my personal favorite. All right. I do believe that cats are the fuel the internet runs on. So now all we're going to do here is we are going to go into our vector here. We're going to say cats I dot reset, and we're going to make a new cat object. Now that we have that, what we want to do is say cats I dot play. And we're going to tell the cat to play with their very favorite toy. Seems overly simple, and well, it is. It's simple by design, and that's what I absolutely love about this, is you don't really need to be a rocket scientist to really wrap your head around this complexity. So when our program runs, we're going to call test. Test is going to come in here, and it's going to create a new shared pointer for a toy, and then we're making a vector of QSharedPointer cats. And then we're just simply saying reset with a new cat. Notice what we're doing here. We're actually resetting that QSharedPointer. So QSharedPointer reset, same as clear for standard shared pointer compatibility. This is what I'm talking about. Under the hood, Qt is very, very aware of the standard library, and they try to maintain compatibility as much as possible. All right, without further ado, release the cats. Let's see these little guys play. All right, so we've constructed our toy, we've constructed our cat, and we are playing around with this toy, and then all cats are eventually done. And guess what? All of them are automatically destroyed. We don't have to play around with any of the memory complexity. It just works. So this is the stuff of magic. You want this in your applications, especially production applications, because the last thing you want is memory issues. This section is going to really focus on the Qt container classes. In this specific video, we're talking about QList. So it's a template class, and it does not inherit QObjects. So there's no signals and slots or anything like that. But because it's a template, you can put QObjects inside of it, which is actually fairly common, and it's part of core. Now, in case you're wondering, really, what is this thing? Well, it's just simply a dynamic array. It's very, very easy to work with, as we're about to see. So first things first, let's go ahead and just make a list. So I'm going to say QList. We need to give it a type, list, and then from there, it's easy to append to. We can simply say something like list 1, 2, 3. Very easy to do that. You can also do something like this. I minus 0. That would have been interesting. And then you can just say list.append. As long as you're working with the same type, it just works. It's ridiculously easy to work with. And if you wanted to, you could do something like this. Let's go ahead, save and run, and see what that looks like. You can see right in our QDebug, it has QList, and then it has the values in there. Makes it just very, very simple. Now I'm going to copy and paste some code from off the screen, plop it in here, just save a smidge of time. We have length, size, count, and count. Notice I've got count in here twice. So if we just highlight it, hit F1, you'll notice that length is the same as size and count. Now wait a minute, why do we need 3 of these? Some of these are in here for legacy reasons, some of these are in here for compatibility with the standard library. So for example, if you go to size, you can see it returns the number of items in the list. But remember, length was the same as size and count. So if I go to count, returns the number of occurrences of a value. We didn't supply a value, so it just simply returned size. If we do supply a value, it's going to return the number of instances in there. So for example, we're looking for number of 4s. There is exactly 1 in there. Sure enough, 1. Simple, easy to use, and it's pretty self-explanatory. It's really so simple, it's almost frightening because it's very intuitive. For example, if I wanted to replace something, I would just say list.replace, and there it is. So we're going to replace 2 with 99. And we can also add some things to it and then remove them. So let's just go ahead and do like 3, 3, 3. I'm just messing around. Let's go ahead and say list.remove. And we're going to go ahead and remove 3. From there, I'm going to just copy paste some code, just speed this up just a smidge. All we're going to do is a for each integer in our list. Let's go ahead and print that out, see what that looks like. Now you notice we still have some 3s in here, even though I said remove 3. Well, what just happened? It hit the first occurrence and voila, got rid of it. So that's a common pitfall that people make is they go, oh, well, I'm just going to remove, and they expect it will remove them all. Of course, again, it is very intuitive, so I'm going to say list.remove all, and there you go. Very simple, very easy to understand once you wrap your head around it. Again, little copy and paste action off the screen. In case you ever have a formatting issue like this, you can simply highlight it, right-click, and auto indent selection. Let's go ahead and save run, see what that looks like. And sure enough, now there are no more occurrences of 3 in there because we did that remove all. We can also do some fairly simple things, but it's almost expected nowadays. We can say something like, we want to get a slice. Now, when we talk about slice, it is very self-explanatory. Think of this as like a giant cake. We want to take a slice of that cake. So we're going to take from 2 to 3. What this is going to do is return another list and put those values in there. So I'm going to just grab a bunch of code off the screen, paste it. We're just going to print out our slice. We're going to print out our list, and then we're going to look at contains. So the original list, does it contain 6? What is the index of 6? And then again, we want to look at the link size and count. Let's go ahead, save run, and see what this looks like. All right, so our slice here is 99, 1, and 2. Our original list is 1, 2, 99, 1, 2, and 4. That's exactly what a slice does. You're taking like a slice of the pie. We asked it, hey, does it contain 6? Well, no, it doesn't. Index of gives us a -1 if it does not exist, or it gives us the actual index, the zero-based position of the item. And then you notice we have this list clear, and then we're returning link size and count. All of those are now zeroed out. Now, if you're coming from Qt 5, you're probably asking, what about QVector? And if you're just starting brand new with Qt 6, you're like, what is QVector? Well, QVector was meant to be kind of like the competitor for the standard library version of Vector. However, that kind of became QList, and there's a lot of confusion. So basically, when they wrote Qt 6, they just basically said, you know what? Why have QList and QVector when they're pretty much identical? So now QVector is an alias for QList. So instead of having 2 classes, they simply have 1. So let's go ahead and say QVector int, and let's call this v. And then we can do pretty much the exact same thing. I shouldn't say pretty much. We can actually do the same thing because it's just an alias. So what does that really mean? So if I highlight this, template type name class QVector is an alias for QList, meaning if you try to use QVector, it's just literally under the hood going to use QList, which we covered in the previous video. This is ridiculously simple. Save and run, and let's see what this looks like. You notice how even though we're doing a QInfo on our vector, it's printing QList because that's the alias in action. So all those arguments and debates and late night conversations that developers had. I really don't think they spent a lot of time on it, but people would basically have holy wars in forums about whether you should use QList or QVector. All those arguments now go away. They are literally the same thing. QVector is just simply around for historical reasons in case you used QVector in your Qt 5 code. They didn't want to make any breaking changes. Let's go ahead and take a look at QSet. So what is it? Well, it's a templated container class, just like what we talked about in the last two videos. But why does it exist? Fast lookup, and I mean really fast lookup. So if we just simply plop QSet in here and hit F1, you'll see it is a template class that provides a hash table based set. What does that really mean though? It stores it in an unspecified order, keywords, unspecified order, and provides a very fast lookup of values. Internally, it implements as a Q hash. Now, a Q hash is basically like a representation of the data, and it allows Q to, you guessed it, very, very quickly figure out where something is. So if you have some really time-sensitive application where you can't sit in memory land for very long, use QSet. The API is very, very similar, so you can just simply work with it using what we've already covered. But I'm going to just, kind of hash out, no pun intended, some code real quick. So we're going to say QSet, QString people. So we're making a set of strings, and then we can, of course, do something like this. Again, very, very simple to work with. Notice how I've just kind of hand jam those in really no specific order. And then I'm going to go ahead and say people.insert, and we're going to insert Rango, our little dog. He's not little, he's probably bigger than I am. He probably needs a diet at this point. But you'll notice something specific about insert. We're inserting, but it's asking for a value, not a value and a position. It's not saying, where do you want to insert it into? It's just going to say, give me what you want to put in there, and I'll figure out where it needs to go. From here, I'm going to do the old copy paste. You'll notice how this is in no specific order once we print this out. Now, the order is not going to make sense to us, but it makes sense to the computer. So there's Rango, Heather, Brian, Chris, Tammy. Notice that is not in the order we entered them in. That's what I mean by it's an unspecified order. This is very fast lookup. And unfortunately, this little example is not doing it justice. I'm just simply showing you that the API is very, very similar. So I'm just going to put a note here, very, very fast. So we can say something like QInfo. I could actually spell QInfo. There we go. So we're going to just simply say, does it contain Brian? So what's going to happen under the hood here is it's going to go out and say, hey, go through each item and figure out where Brian is. But because this is a set, it doesn't necessarily have to go through each item. It's going to create a hash of this, and then it knows internally where that hash is. So it's a list string fast compared to a QList. Now, I know this gets a little bit confusing, but what's really the difference between list, vector, and set? Well, list is whatever order you put it in. Vector is an alias towards list, and set makes a hash under the hood and orders it in the order it wants to do it, so it can provide fast lookup. Let's talk about QMap. Now, what is it? Well, it's a templated container, but it exists because it has a key value pair. Wait, what do we mean key value pair? That's right, you have a key and a value. The key associates to the value, but the value does not necessarily associate to the key. What that means is you can have some sort of identifier that is beyond just a normal positional index. We kind of glazed over the index aspect of the last few classes, and I really wanted to address it here because this is where it deviates. Let's go ahead and take a look at this. So I'm going to just simply snag that, and let's go ahead and do something like this. So I'm going to say QMap, and now we need to define the key type. So I'm going to say QString, and then the value type, which is going to be an int. And let's call this ages. From here, we can say ages dot, and I'm going to go ahead and do an insert. And notice now it automatically knows, hey, we have a key as a QString and a value that's an int. It's going to be really dependent upon what types you put in there. But now that you defined a type, you got to stick with them here. So I'm going to say Brian, and let's say I'm 44. And then we can, if we wanted to, just the old copy paste, just make life very, very simple for us here. Go ahead and switch this to Tammy. Say she's 37. And then let's go with Rango, our dog. And let's say Rango is going to be 15. He's an older dog. He just kind of lays around and snores all day. I'm a little envious of that, I got to admit. Now, this is where I'm going to slow things way down. I know I've been doing a lot of copy and pasting in the last few videos, but this is where I'm going to really dial it back and explain some things here. So we're going to say QInfo. Maybe, if we can get through my horrible typing here. We're going to look at the keys. Notice how that is a queue list. We already know how to work with queue lists, so this is very, very simple. I'm going to grab this. And let's go ahead and look at the values. The values are also a queue list. So we have two different lists here. Let's go ahead and save and run this just to really demonstrate that. It's not going to come out as some weird map type. It's just going to say queue list and queue list. We have keys and we have values. But now how do we associate a key to a value? Oh, okay. Well, let's look at this here. What we could do is something like this. We could say Brian is, or whatever name you entered in there. And let's go with ages. And then a normal list, you would do a position, like 0 for the first position, 1 or 2. It doesn't make sense in the context of a map, but that's how a normal queue list, queue vector would work. Instead, you have to use the key, and the data type is a string, or I should say a QString, so we're going to give it the actual key. It's really that ridiculously simple. Let's go ahead, save and run, and see it work. So what happens under the hood here is it's going to go through our map, and it's going to say ages, look for a key. And it's going to find that key and then look for the value associated with it. You're inclined to think that it's positional, but that's not implicitly guaranteed. So be a little wary of that. 9 times out of 10, yes, I'll admit, it is positional under the hood, but don't necessarily count on it being at a specific position. This also has an eerily familiar API. For example, we can say ages.remove. Let's go ahead and remove Rango, our little puppy dog here. Now we can actually double check. So I'm going to say QInfo contains ages.contains. I did say I was going to slow this way down here. You notice something right off the bat, though. As soon as this thing runs, we added Brian, Tammy, Rango. Brian, Rango, Tammy. Did you notice the order is different? Brian, Tammy, Rango. Brian, Rango, Tammy. You might have guessed there's some sort of internal hashing mechanism going on there, and you're absolutely correct. It provides a fast lookup based on key, not necessarily on value. You have to access the value through the key, but it does provide a fast lookup mechanism. Probably not as fast as QSET, so if you're looking for something really time intensive, I'm going to admit I just simply haven't tested it, but it should be seriously fast compared to what you're probably expecting. Now, what we can do here is do a for each, and let's go ahead and say QString key in ages dot keys. What we're going to demonstrate now is just simply how to navigate through this and get a list of all the values based off a key value pair here. Say QInfo. Go ahead and print out that key. And of course, there are different ways of doing this depending on what you're comfortable with. I'm showing you just a very simple, down-to-earth way that pretty much every skill set can understand. And we're just going to say ages, and now we want to access that value, so we can say whatever that key is. Go ahead, save, run, and let's see what that looks like. Ta-da! So now you have your key value pairs. Very, very simple to work with. Now, somebody who's really been paying attention is going to notice that if you go in here and you say dot value, that's right. You can actually just say you want the specific value of an item. So let's go ahead and do this. We'll say QInfo. And I want the value of test. Now, notice what we're doing here. We're giving it a key that simply does not exist. We also have the ability to add a default value. Now, if you're wondering why it's saying, uh-oh, why are we doing this? Because we have to maintain the type. So it does strictly enforce that type. Now, if we try to look up test, it's going to give us, you guessed it, a -1 because it's simply not there. Now, what happens if you were to try to modify a value here? So let's say ages dot value. You notice how it gives this to us, but it's a const, so we can't really update it. What we have to do is something like this. Let's say Brian equal, and let's say I'm really, really old now. I'm 99. And then we can just grab this. Save, run, and let's see what that does. So now Brian has been overwritten with 99. So it's very, very easy to replace that value. Now what happens if we take this, remember it was a -1, and we just try to access a key that doesn't exist. We haven't actually added that. And let's say this is 222. And now we're going to try and reprint this out and see if that key's even in there. We got 222. Why? Because what happened was when we went to access this and said, hey, this key equals this value, it's going to not find it and say, oh, let's just go ahead and insert it. So it does it automatically for us. So it doesn't generate some sort of error or anything like that. This video is going to cover QString_list. Now, you're inclined to think this is just a QList of QStrings, but it's actually not. It's better than a QList of QStrings. QString_list inherits from the QList, but it actually adds a lot of functionality to it. And if you just highlight it in F1, go in here, you can see it inherits from QList QString. Like QList, QString_list is implicitly shared It provides fast index-based access, but it has a lot of string functionality baked right into it. This is actually pretty powerful. I like it. It's one of my favorite classes. It's just kind of weird when you talk about a programming language and you're like, this is my favorite. But anyways, so we're going to say names. Let's go ahead and add this in. We're just going to initialize that. And then we can actually append it as we see fit. Very, very simple, very similar API. So it really becomes quite boring, which is actually a compliment, because we don't want to have to sit there and spend all day reading the documentation. We can just work with this and everything works as expected. Now, this is where the fun part comes in. You're inclined to think, okay, it's boring. Why should we even talk about it? We've already covered this. Well, it's got some string stuff baked into it. So you can do things like this. Names dot replace in strings. Isn't that really cool? You'll notice something right off the bat, though, is there is a string view. We haven't really talked about views, but basically it's read-only access. So there's different ways of doing this, but in case you see the view part, whenever you see view, it means read-only access, but there's other ways of doing it, obviously. So we are going to say we want to replace A with the @ symbol. Go ahead, save, run. And sure enough, every single A has been replaced. So you don't have to write some exhaustive function or some sort of modifier or anything like that. You can just use the baked in functions and modify all those strings right in place. It's actually really, really cool. So I'm going to grab this. We're going to just flip that around. But I also, you know what? I feel like sorting. So I'm going to say names.sort. And notice you can sort based on case sensitivity if you really wanted to. And now they're sorted, Brian, Heather, Rango, Tammy, and they're sorted in alphabetical order. If we had done case sensitivity and we had different case sensitivities in there, it would have done that as well. So it becomes very, very simple to work with. Now, one thing I absolutely love doing is taking that string list and just joining it into one string. Makes it ridiculously simple. And you'll often see newbies writing code that will, take a string and then loop through it. No, you don't have to do anything like that. You just simply call join and it works as expected. So we're going to grab this. Say run, and let's see what this looks like. Sure enough, it's just one string now instead of a queue list under the hood. Now, from here, you can do some other things, like you can actually filter. So let's say we wanted to go with a queue string list. Let's call this my list. You can tell when I run out of names for variables, I just start saying my and then whatever it is. Names.filter. And we want to filter based off an R, a lowercase r in this case here. Let's go ahead and say queue info my list. Say run. Let's see what that looks like. So only things that had a lowercase r are now in our filtered version of that list. It just makes life super easy. You don't have to do a lot of craziness. You don't have some weird arcane format you have to follow. It's just very, very intuitive. Now to wrap this up, let's do something very simple here. I'm going to say qstring me equal, and then just whatever your name is and that you've put in that list. And then I'm going to say queue info. And let's see if it just contains that name. We already know it does, but just in case, there's the proof. Let's go ahead and grab this. Now, unlike a map, this is actually a queue list. So everything's indexed or positional based. So let's go ahead and look for that. I'm going to say index. So we're going to get the index of whatever we're searching for here. So it's at the 0 position right here. Now I want to just take this let's go ahead and get that value here. So what I'm going to do is just get this guy and say names.at. Now this is actually the preferred way, at, because it's going to give you a const reference, meaning you cannot modify this, as opposed to doing something like this. So we're just going to say names at whatever the index of, and it will just work. Absolutely one of the simplest things you're going to work with here. It's very intuitive, very easy, and once you wrap your head around the basic QList API, the very first video, you can pretty much work with most, if not all of these, without even looking at the help file. Let's go ahead and take a look at QDeleteAll. So QDeleteAll and QList, what is it? Well, we want to put Q objects inside of a QList, and we want to be able to delete them all. Now, I shouldn't say just Q objects. You can put any type of pointer inside of a QList, but remember, Q objects cannot be copied, so we have to work with a pointer, and that's where the problems start. So I do have our little test class in here. This does absolutely nothing. It just has a constructor, a deconstructor, and we are just seeing it as constructed and deconstructed. Just want to view that object lifecycle. There's really no magic to that. So let's go ahead and crank this out. So I'm going to say void, and let's go ahead and test list delete. Kind of the most obnoxious function name on the planet, but that's what we're going to name it. We're going to plop it right down here, so it's going to run as soon as our program starts up. Now from here, I'm going to say QList, and let's go ahead and say test. And we want to work with pointers because we're working with a Q object, and the Q object cannot be copied. Now let's go ahead and say let's create a bunch of them here. So I'm going to say for int I equals 0, I is less than 5, I plus plus. You can create as many as you want. It really doesn't matter. Let's go ahead and append to our Q list here. And this is where the problem's going to come in. I'm going to say new test. You notice what we just did here? We just created a potential problem because now we have a pointer we have to manage. So I'm going to say null pointer. And let's go ahead and call this item with QString and whatever the number is. We're just going to convert that number into a QString representation. So now we've got some pointers in there, and we need to manage those pointers. Just to test that, I'm going to say for each, and we're going to just go through this whole thing here. So we want each pointer to test in our list. Now we've got a fundamental problem here. Let's say we wanted to really work with this thing, but we've got these pointers. We can either do a for each and then call delete on each one, or what we can just simply do is QDeleteAll and then give it a container. Notice it says container, not QList. So it doesn't really care if it's a QList, QVector, QSet, QMap. It's just going to work its magic on pretty much anything we throw at it here. It's going to go through and says, is it a pointer? If so, great. And it's going to wipe it out. Now let's go ahead and click F1, and it's going to say deletes all items in range from beginning to end using the C++ delete operator. The item type must be a pointer type. That's the major takeaway here. So if you use this on a container, any pointer in there is going to get deleted. So you got to be a little bit careful if you don't want them all gone. But you'll notice that QDeleteAll doesn't remove the items. That's key. It doesn't actually remove them. It merely calls delete on them. That is also a source of problems. Okay, let's dive in and let's see what's going on here. So if I just simply say QInfo, and let's just go ahead and grab the first item, what's going to happen here? Well, we have to be a little bit careful here. We have a memory issue, and I'm wondering if you can spot it. Just in case you haven't, or you're sick of waiting on me, we've created it, we've deleted it, we're trying to access it. That's called a dangling pointer. And it's very bad, because this is what's going to happen to our application. Let's go ahead and save and run, just to demonstrate what's going to happen here. You notice how it says, press return to close this window, meaning our application crashed. So we've constructed the objects, we've listed them, and then we've destroyed them. And after it's been destroyed, we're still trying to access it because that item's still in the list. Oh, that's not good. We can, actually, if we wanted to, test this out even further. And let's see how many are actually in this list. We're still going to crash, of course. But it has 5 items in there, even though we already called delete all. That's a little frustrating. So I almost wish there was an optional parameter to clear it. It'd make life a little bit simpler, but it's very simple to just say clear. The big caveat, the major takeaway here is if you're going to use delete all, you have to know what you're doing. Once you use delete all, you should clear unless you're going to reset those pointers somewhere else. Now it's going to crash this way. Why? Because we still have that dangling pointer. When in doubt, actually comment it out correctly. And then once you clear it, it no longer crashes. It's still saying 5 because we're doing that count before. And that's what I mean by you got to be a little bit careful because this can get really, really deceiving. Let's go ahead and move him down here. And now we should have a count of 0 here. Ta-da! So if ever you're working with a container and you call QDeleteAll and your application suddenly starts crashing, this is exactly what's going on right here. Now the last video, QDeleteAll, was, well, ridiculously easy to work with, but it had some minor flaws. We're going to fix those flaws by using a smart pointer. You can absolutely use the standard library smart pointers, but I'm just going to use the Q shared pointer with a Qt list just because, well, surprisingly, we're making videos on Qt. The reason why we have to do this is because Q objects cannot be copied and we have to work with pointers. So let's go ahead and make a test function here. Test list auto. I'm just trying to see just how obnoxiously long I can make a function name here. I grab this and let's just plop it right in here. So it'll be the first thing that runs in our little application. And we can just simply say QList. And now we have some challenges here, especially for kind of newbies. We have a template, but we're going to use a template in a template. So we have to say Q shared pointer. And you notice it looks a little bit confusing, but it's pretty simple to wrap your head around once you get used to it. So we have a QList that has a QShare pointer, which is using a test class. Now, remember our test class just has a constructor and a deconstructor. There's absolutely nothing going on in this class. We just want to see it's constructed and deconstructed. All right, so once we got to this point, let's call this list. And then I can say for int I equal 0, I is less than 5. I'm just going to snag this, the old copy and paste. Strikingly similar to the last video. All we're really doing is we are just, instead of adding a raw pointer, we're wrapping it in a smart pointer. And it just makes life so much simpler. Now we just simply add it. And then we can work with it directly. We can say, for example, for each. And this is why people tend to use typedefs when they start getting into this sort of stuff, because it gets to be a bit of a chore unless you already have it queued up on your clipboard. You know, you got to retype this over and over again, so they'll just use a typedef. I'm not a huge fan of using typedefs, especially in tutorials, because it does get a little bit confusing for people that are either new or English is a second or third language. So we can just show that pointer there. Now I'm going to go ahead and show you what happens when I just remove one item. So I'm going to remove at. I actually could have done remove first, but we're just going to remove at. And then we're going to clear it out. Notice what we're not doing. We're not paying attention to memory at all. We don't care. We want the smart pointer to be smart and do its own thing. So let's go ahead, save and run, and see this in action. All right, so we've constructed our objects. We're working with our objects. We remove one, and you can see it has been deconstructed automatically. And then we're going to just go ahead and clear the rest of the list, and ta-da, they all magically deconstruct. So most of the time in a production level app, I will almost automatically go right to a smart pointer. Why? Because you don't have to mess around with memory. It's really just that simple. It's that straightforward. All right, I'm often asked the question, how do you work with QDeleteAll and QMap? Well, it's very much the exact same thing. So we're not going to waste a lot of time explaining because we've already done this. We're just going to simply do it with a QMap. The reason why is because QObjects cannot be copied, and we often end up working with pointers. All right, so we're just going to take our QMap here. We're going to give it a key of a QString and a value of our test class pointer. Now, yes, quick recap, our test class does absolutely nothing. It just has a constructor and deconstructor, and inside the implementation, we just see that it's constructed and deconstructed. Just want to see that full object lifecycle, just in case you missed it. Now, from here, I'm going to say for int I equals 0, I is less than 5. Go ahead and increment that. And then let's go ahead and we're going to simplify this a little bit and say string ID equals, and I want ID dash. Actually, let's get rid of the spaces there. In case you're wondering why I'm doing this special format, this actually came right out of some feedback from the older course where somebody was like, well, I've got this problem, I'm working with this map, and how do I do it like this and that? So I just kind of took the whole answer to that question and overly simplified it. So we're going to do a name, and then we can just the old copy and paste. So what we're doing here is we have an ID, which will be the key, but then we have the name, which will be the name of the object. Seems a little bit redundant, but that was the question that they had asked. All right, so we're going to say map.insert. Let's go ahead and add that ID, which is just a QString, and then we're going to say new test. Remember, because we're using the new keyword, we're automatically in pointer land, and we have to manage that memory. Then we're going to use that name, which is also just a QString. So the fundamental thing they were getting confused on is the key the object name? And no, you can actually set it, but it's not interchangeable, meaning if you set the object name, it's not going to magically change the key and vice versa. So that's what they were really, really confused on in terms of QObject. What we're getting at here is that the object itself is not the key. The QString is a representation of the key. We have a bit of a boo-boo here. Let's fix that. So we're going to do for each item in our keys. Let's go ahead and look at this. Say Q info item. And let's go ahead and look up that item based off its key. Now, if it seems a little bit misleading, you can absolutely just simply call this a key. That was another question I've been asked in the past is, does it have to be named item? No, you can name it key, you can name it kitten, you can name it whatever you want to name it. It's just simply going to work. Now comes the fundamental problem. We have created these classes, now we've got to delete them. This is where Q delete all really, really shines. Just going to simply say, give it our map. And then we're going to say map.clear. Because remember, Q delete all will not remove the items, it just simply deletes the items out of there. So let's go ahead, save, run, and let's see this in action. Sure enough, we have our constructed, we're working with the item, and then they are automatically deconstructed. That is extremely cool. Now it's very powerful, very easy to use, and I am going to just copy and paste something in there in case somebody looks this up in the source code. Yes, if you try to access it after a delete all, you're using a invalid or dangling pointer, and you're going to have a bad time. This video, we're going to answer two questions. How do you work with Q shared pointer in a QMap, and how do you use a typedef because typing all that out becomes just a royal pain. We're doing this because Q objects cannot get copied and we want to use smart pointers, but smart pointers have a very verbose syntax. So we're going to use a typedef, and I'm just assuming you paid attention in C++ class. A typedef takes a complex type definition and gives you a friendly alias that you can define. So imagine, if you will, we wanted to work with a QMap that has a Q string for a key, but has a Q shared pointer for a value, which is also a template of the test class that we've been using. And we don't want to have to retype that every single time. So instead, I'm going to just call this test map. So now, if I just take test map, and let's call this map, that's it. We don't have a ton of typing. We don't have to retype this every single time, and voila, it automatically knows what it is. Now remember, our test class again is just a constructor. Deconstructor does absolutely nothing other than show us the object lifecycle. And it's very, very simple to work with. So from here, I can just say for all right, let's see here. Just grab something off the screen, do a smidge of copy and paste so it doesn't take me a minute to type that out. Sometimes I think copy and pasting is faster. Other times I get all messed up and it actually takes a little bit longer. So I try to find that friendly balance there. So now we're just going to create a Q shared pointer. And yes, you can absolutely make a typedef to that if you wanted to. I do caution against that. I actually don't use typedef a lot in my tutorials because it can get very, very confusing what something is. And you'll find if you have multiple developers making multiple typedefs, you're going to end up with redefinitions of the same thing because two different people make two different typedefs pointing to the same thing, basically. All right, so now we are just simply wrapping a new instance of our test class into a Q shared pointer. And from there, we can simply say map.insert our ID or our key with our smart pointer. That's it. It's just really that simple. The big caveat here is that typedef will make typing a little bit easier, especially if you're going to do it over and over and over again. But I don't really use them a whole lot for my tutorials. I used to, but I had too many people go, wait a minute, what is this thing? I don't understand what you're doing. And then it just became too cumbersome, and I said no. All right, now in here, I can just simply say Q info. Now we can actually, if we wanted to, work with the QShared pointer or work with uGetIt, the actual pointer. And if you're ever concerned, you can just use data and then whatever it is, just to make sure you're working with the actual pointer. It becomes so simple, you don't even have to think about memory, and that's what I absolutely love about this technique. And then when you're done, you can just clear out that map, or it will clear it out automatically due to scope, and you don't even have to worry about it. Let's go ahead and save, run. And voila, we have all our constructors. We're working with our item, and then they automatically deconstruct out of the map. This is absolutely beautiful, and if you're working in production, can save you a lot of time and headache. The big cautionary tale here, though, if you're going to use typedef, make sure everyone who's working on the code uses the same typedef. One major source of confusion for newbies is the view class. Now, whenever you see the word view in Qt, instantly think read only. Now, there is a concept, it's a little bit more advanced, but it's called a model view controller, or MVC programming. So that is vastly different than what we're talking about, but the concept still applies. Is a view is usually just how you view the data or read only. So whenever you see something like this, think of the letter Q, means it's in Qt. We have a thing, a string, okay, and then we are viewing it, meaning it's read only. So a QString view is just that. It is a read only subset of a QString. This may sound super confusing, but think of it in these terms. You have some data, in this case a string, you want to display it to the user, but you don't want the user to be able to directly modify it. Hence, QString view class is born. You want to be able to view the string but not modify it. The major takeaway is a view is read-only, and it simply points to the actual data, it does not own it. Okay, I'm going to give you a rather simple example of a Q byte array view. Again, remember, Q means it's in Qt, byte array means we're working with a byte array, and view means read-only access. And that's exactly why we're doing this. We want read-only fast access to a Q byte array. There's a bunch of reasons why you may want to do this, but let's just look at a simple example here. I'm going to say void, and let's call it display. Now, as the name might really imply here, we want to display some information, but we don't necessarily want to modify that information even in the function itself. So for example, there's a bunch of different ways we could do it, but what we're going to do is we're going to say Q byte array view, give it the address of a view. There we go. Now, anytime we work with this view, we cannot directly modify it. However, we can work with it and parse it and do things of that nature, but we cannot modify the underlying data. Let's go ahead and dive into this. So I'm going to say Q byte array. Notice we can modify this, and this is going to be our bytes or our data. I'm going to say, hello world, how are you? Nothing super fancy, just, good hello morning message kind of thing. Now we're going to say Q byte array view. This is our read-only copy here. Now, when I say read-only copy, what I'm talking about here is we're not actually copying the byte array, we're just simply pointing to it. So now I have to tell it what we're pointing to, our bytes. Now this is where it gets a little bit interesting. I'm going to say display, and we're going to hand it our view. Notice what's going on. We can either work with it directly, or we can actually copy it, because guess what? The Q byte array view is not a Q object. So we can copy this all day long if we really, really wanted to. But the copy doesn't impact our original data. So which one should you use? Well, it's really a design choice. I tend to do this just because I want to make sure that my applications stay high performance and I'm not making copies all over the place. But guess what? Q byte array view is very, very small. And even though it's small, it is very powerful. So let's go ahead and save, run, and see what this looks like. Okay, it looks like we just have a Q byte array, but guess what? We cannot directly modify this. We can't say view.insert. Notice it's just not there. Or remove. It's just not there. That's the whole point of a view. We can, through the magic of copy and paste, just do some simple things like determine the size, get the data or the const data, get a slice. That's right. You can say from the starting position to a certain length. You can, say, does it contain something? What is the value at? What is the current value at an index position? And get the index of a certain character. This is actually pretty darn flexible. You can even do simple things like this. For again, as long as you're not trying to modify it, you're going to be just fine. Now, the whole point of this thing is very fast read-only access, and that's exactly what it does. Again, there's multiple ways to make something so you can't modify it, but there's always that risk that you could try to modify it inside the function or do some other workaround. And, well, view classes are a handy little way of avoiding any of those pitfalls. It just works as expected. All right, let's go ahead and cover the QString view. Again, this is read-only fast access to a QString. And once you've got the API down, it's virtually identical to what we just talked about with the QByteArray view. Let's go ahead and make some data. So I'm going to say QString. Let's call this data. Hello world, how are you today? Very simple, doesn't have to be rocket science. And then we're going to make a QString view. Go ahead and call this view. And we're going to go ahead and hand it our data. Again, the view is a read-only view into that data. You cannot modify it, and it does not own it. And we can, of course, make another little function here. And this is going to be identical to the previous one with a few minor changes. I'm just going to save a lot of time, copy and paste this out. There we go. So really all we're doing is we're displaying a QString view, and it's going to look on the screen like a QString, but we cannot modify it. However, we can do things like get the size, get the const data, slice it, see if it contains something, get the count number of letters, get something at a certain position, get it at the index, and you can say index of, meaning where is this thing actually at, and you can do for loops and all sorts of things. It is really, really streamlined, and it's one of the classes that I've come to love, especially when you start working with classes and you need to return something like, let's say, a person's name, but you don't necessarily want the consumer of that class to change that. Again, once you get the API down, it's really ridiculously simple to work with. The big takeaway is don't try to change the data. One question I'm often asked, and I'll admit this leads to a lot of confusion, is how do you persist your application state? I mean, when you throw out words like application state, I mean, all these images come to mind, especially if you're in a mobile platform. But really what we're talking about is settings. So for example, this browser, I have a particular theme. I have it on light. I have a home page. I have all these different settings, bookmarks, for example. And when I close the browser, I expect those settings to be saved somewhere. And when I open it, I expect all those settings to magically come back into the application. It's exactly what QSettings does. It provides a persistent platform-independent, keywords, platform-independent application settings. Its API is ridiculously simple, and instead of diving through the docs, we're just going to generalize it in this image. You have an application, you have some settings, X and Y. You want to be able to save that down to storage. From there, when your application's loaded back up, say you rebooted the computer or whatever, you want to be able to load that back from storage and repopulate those variables exactly the way they were before you closed. This is simple, but it's also extremely powerful. Let's dive in and take a look. Okay, let's take a look at QSettings. I'm just going to highlight it, hit F1. You can see it is part of QCore and it is not a QObject. So of course you can copy this anywhere you want. If you look at this, first thing that really sticks out is QSettings API is based on QVariant. Remember, QVariant is just a wrapper around data types. It does this because it wants to really make that data type ambiguous. It doesn't really want to care what the data type is. It just wants to say you have some type of data and I'm going to put it somewhere. So this actually becomes extremely flexible under the hood. Let's go ahead and at first glance, it doesn't seem like there's a whole lot here, but you may be asking yourself, how do you do things like set the organizational name, the domain, things like that? It's already baked into part of your application. Note we use QCore application for console apps, so I'm saying QCore application. And we can go ahead and set the organizational name. And just set it to, whatever your company is. If you don't have a company, you just put your name. You can say, what's your domain? Things like that. It's just kind of expected, but this is how you would set it across your entire application. So if you really wanted to pull that information out at some other time, it's right there at your fingertips. You just access the core application and you've already set it. So for example, let's say I wanted to set the application name. Go ahead and set this as tester. Notice what we're doing though. We're setting an application name, but it's different than our project name. Yes, that's actually perfectly allowable. Just understand what you're doing is you're setting this in your settings, not necessarily in the computer itself as far as the process is concerned. Let's go ahead and flesh out some functions here. We want to be able to save and load. So I'm going to actually do 3 functions: information, save, and load. So I'm going to say void info. And let's go ahead and say Q settings. Now, yes, you could make a copy if you really wanted to. I'm just going to avoid the copy altogether. Now, from here, I'm going to say Q info. You may be wondering if there's a penalty for copying. There's really not, to be brutally honest with you. A lot of the old school programmers really in C++ land hate copies because we're used to working with much smaller computers with a lot more limitations. So I'm going to say we want to get the actual file name. And then we want to get the keys. Now, this may be a confusing concept at first, but really what we're talking about is we're putting everything into a file. And in that file, it's kind of like a flat file dictionary, if you will, meaning it's got key value pairs. We've talked about this with QMAP. I'm going to say all keys. And if we just highlight that and go right to the help file, you can kind of see what we're doing here. We are making a key value pair. Whoops, highlighted the whole thing. But you get the point. You have a key and a value. Key value, key value. That's really all we're doing. And because you've already learned about QMAP, now you understand the concept of a key value pair, and it's very, very simple to wrap your head around. Now I'm going to we're going to make 2 more functions here. Let's call this one save, and let's call this one appropriately load. Let's go ahead and flesh these out really, really quick. So to save, I'm going to say settings dot set. Now, whenever you're in Qtland and you want to set a value, you always start with the word set, and then you get all the functions that let you set them. That's why when you have a variable and you right-click in the IDE and go to Refactor, it'll allow you to do a getter or setter, and it does all of that for you. But just when you're in Qtland, type the word set, and there you go. All right, so we're going to set the value, and notice it wants a key and then a value, and the value's got to be a Q variant. So I'm going to say our key is test, and you can do this one of 2 ways. You can say Q variant and then wrap whatever you want in there, or you can just let it cast it for you. I almost always let it cast it for me just to save myself some typing. But notice what you're doing. You're saying settings, set value, key value pair. Now we can do something like this. We can say Q info. We want to get the status. Highlighting the status, you see it returns a status codes indicating the first error that was met. So this is really if we're looking for any type of error. And of course, no error is 0. So 0 is good. But you may have like an access error or format error. Access would be like you have you can't write to the disk. Format would be like there's something wrong with the INI file name. Notice the INI file name. If you're on a Windows machine, this is going to try and do it to the registry unless you specify an INI file name at the creation of the class. Sorry, I got a little tongue-tied there. But all other platforms, it's just going to be a flat file. All right, so now that we've got that, I'm just going to simply pump out saved. Notice what we're not doing. We're not expressively telling it, go save this. It's just going to do it automatically. Now for our load, I'm going to say qinfo. And we want to take our settings and we want to do the getter. So we're going to use a key. And now we have a default value. We don't necessarily need this. I just wanted to show you, you can do it. So if you want to say, I need a default value, you can go ahead and just put it right here. And if the key is not found, it will give you the default which you defined. But because it's a Q variant, we need to tell it what we want it, what specific data type. So I'm gonna say toString. But you remember, we gave it an integer, not a string, but we can definitely convert it. It's very simple to do that. We can take the same thing and get it as toInt. And notice there's a little bool where you can hand it to determine whether or not that went correctly. And in case you're wondering how to do that, you can just say really, really simple. Just let you know that, hey, something bad happened, and then you can print out some sort of error message on the screen. You can say like qinfo. Could not convert to int, or whatever you wanted to do. But it's really ridiculously simple to work with. Basically, you either have a getter value or a setter set value, and then you have a key value pair. When you're setting, you need both the key and the value. When you're getting, you just need the key, but you can optionally include a default value. Okay, let's go ahead and bring all of this together. We're going to go right down here, and I'm going to say use settings. And let's just simply call this settings. And now we have some things we can really choose from here. Notice we can do an organization and an application, and you can say scope and all these other things, but we're going to go kind of the easy route here, and we're going to just simply say we want our Q core application. We want our organizational name along with the Q core application name. This is very handy if you have like a suite of applications. You don't necessarily need to do all this, although when you get into bigger, more complex applications, you will definitely have problems if you just simply do something like this. Maybe copy and paste betrayed me there. Let's try that again. Take two. All right, if you just simply do something like that, in bigger applications, you're going to want the organizational name and application. Just trust me on that one. We do touch on that a little bit more in some of the more advanced videos I've done out on YouTube. Now, from here, what we're going to do is we're going to take this settings here, and we're going to say if settings dot, and we want the all keys. We want to know how many we have. So if we have 0 keys in there, we simply haven't saved yet. And this is just a demonstration of how you could save and load. So we don't have any settings. We're going to go ahead and save, and then I'm just going to call our little save function. And then, of course, if we did have settings, we're going to just go ahead and load those out. And of course, we're going to call our load function. Very simple, very easy to understand. We're just going to say, hey, make a Q settings. Again, more advanced applications, you're going to definitely want an organizational name and application name. And then we're going to load up, say, all keys. If it's 0, then we're going to go ahead and save. Otherwise, we're going to go load what we previously saved. Just a simple demonstration. So no settings, Q setting, no error, and we've saved. That right there is our status that we printed out earlier. Remember, 0 is good. So we went ahead and actually saved. But where did it save to? Let's go ahead and pop out to the disk here. And let's flip back here. I'm in 7.2. So it would be this guy right here. Now, let's see here. Is it this little guy? No. Properties? Where is this thing actually at here? Now I'm a little embarrassed about where is it. Let's go ahead and load, because guess what? In our load, we want to know where this thing actually is. So we're going to go this info here real quick. Let's find out where that file is. It has betrayed me. Save and run. All right, so our file is right here. That's why I couldn't find it. It wasn't in my application directory. So this is in home/username, and then in a hidden folder when you're in Linux. Dot means it's a hidden folder, config, and then da-da, notice void realms. Where did we get that from? You guessed it, our organizational information. Very, very cool, very, very easy, simple to understand. Now let's play around with this a little bit here. Let's go ahead and just grab this. We're going to go ahead and just set it without the organizational name, the application name. Ta-da! Notice it's still right there. Why? Because of all of this stuff. Now let's comment this out. And we're just playing around with the settings here just to see if things change. See how now we're saving. So what's happening here, when we run this, you'll see it is a different file altogether. Now it's in config unknown organization. Ta-da! So that's one of the gotchas there, and admittedly that just threw me for a loop because that behavior has changed slightly from older versions of Qt, where it would just dump it right in the application directory. So I guess the major takeaway here is, yes, this does change over time, and this will change on a per platform basis. You may notice different Linux distros put it in different positions. You may notice Windows does it very differently, and Mac, of course, will do it the Mac way. So major takeaways here. I did say this was going to be a bit confusing. You're almost always going to want an organizational name, domain, and an application name. And when you make your Q settings, you're going to want to rebind all that in. From there, you can simply save or you can load. When in doubt, if you're always trying to figure out where this thing is, a handy little trick is to simply use the file name like we did up here in info. Let's go ahead and save run. Now you notice how we had changed some things, but it's going to reload the file we already saved. Because remember, previously we had done that before we commented out all that code. The API for this is very simple, but understanding how it behaves is very complex, and that's something I absolutely hate trying to explain. And almost always I'm telling people, because this is a platform independent, you need to really dive in and read up for your operating system. And even in the documentation, it says this information is often, notice the keyword often, stored in system registry on Windows, but doesn't mean it's always stored in the system registry. And in the property list files on Mac OS and iOS and on Unix systems, in the absence of a standard many applications, you notice how it's doing all these. It could be this, but it could be that. It could be this, it could be that. When in doubt, you're going to want to fully test this for the operating system you're deploying on, because guess what? Even in the documentation, there's a lot of confusion about where this thing's going to actually end up. Let's take a look at something a little bit more complex, groups. Now, why do you want groups? Let's say you have multiple things and some of those keys actually conflict with other keys. We don't want to overwrite the values. So that's where groups really come in. We want settings in logical groups, and we're going to use begin group and end group. This is actually, once you really wrap your head around it, pretty intuitive. So it's a little confusing to explain, but once you get it, it just makes sense. It's unfortunately one of those things. So I'm going to say, we're going to make two functions. We're going to save age, and we're going to get age. Now, notice these are very high level and generic. We're not really defining what we're saving, but we're going to follow a general pattern. I'm going to say Q settings. And let's just, for giggles here, let's work with a pointer. It doesn't really matter if we do or don't. And I'm going to say QString. We want to define a group. Notice what I'm doing first, defining a group. Then we're going to define a name. This is really our key, and then our value. Now, from here, I'm going to say settings. And we want to do a begin group. And we're going to give it the group name. So think of this like dealing with groups of people. You'll have like human resources, accounting, developers. You want to begin addressing a specific group. And then you're going to say setting dot set value. The API is actually exactly the same from this point forward. You have a key value pair. You're going to just set that value. Now we want to, so we don't confuse it with anything else, go ahead and end that group. Meaning I'm now done talking to you. Go away group. Let's go ahead and click that. Appends a prefix to the current group. The current group is automatically prepended to all keys, but now we're actually defining our group. It's not just the high-level global group. Now we're going to go to end group, resets the group that was before. So if we begin a group and we forget to reset it, we're going to keep adding things to the same group. So just think of it like this. When you begin a conversation, you should end a conversation. All right, now things get a little bit more complex when we go into actually getting it. So I'm going to say queue settings. And let's again work with a pointer. Just, you don't really have to. I'm just demonstrating you can. And I want the name. So we've got a pointer to the settings, the group, and the name. What we're going to do first is we're going to simply, you guessed it, begin group. Now, what I like to do is just copy this right here. We're going to get rid of this. So you got your begin group and end group. So you have your beginning of the conversation and the end of the conversation. Now, what I almost always do right off the bat is check to see if it has something, because a lot of times I don't want a default value. I want to say, does it actually exist? So I'm going to say setting contains, and it's looking for that key, in this case, the name. So if it doesn't contain it, then I want to, of course, do something specific. And in this case, what I'm going to do, and I'm going to change this around a little bit here, because this is a getter. It should actually get something. I'm going to just paste in some code just to save like a microsecond of time here. We're going to just simply say, warning does not contain the name of the group. And then we're going to go ahead and end that conversation. And then we're going to return a 0. Now from here, let's go ahead and get that value. So we kind of showed you this before. I'm going to say bool, okay. And then we'll say int value equals, and we're going to say setting dot value. Remember, this is going to be a key variant, so we need to convert this. I'm going to say to int, and let's go ahead and say address of our bool. And then, of course, we want to just kind of replicate this right here, and I'm going to just grab this whole thing. If not okay. I wonder as developers if we ever say that to ourselves, am I okay? If not okay, go get some coffee or something like that. But anyways, point being, let's go ahead and change this around. Could not convert to int. We're just going to give some warning that makes some sort of sense to the user, and then we're going to go ahead and end that group. But notice what I'm doing repetitively. Begin, end, end, end. Whenever you begin, you want to make sure you've actually ended that conversation. Now, what we could do right here is just simplify it and put it up there. That way we don't have end groups all over the place. And then we're just simply return our value. Now, why am I doing all this? I mean, we did have the default value. I'm just showing that you don't have to rely on the default value. You can have some pretty complex logic in here to determine, does it even exist? If not, what's the appropriate behavior I should really take? Again, a lot of this is just design decisions based on you want, and I'm going to do the magic of copy and paste, plop in our test code here. So we are going to save using our settings, people, Brian. Remember, we got group, key, value. So our group is people, Brian. And let's say age is 44. Then we have a beer. That's right, I like beer. So beer is the group we're making, 2 heart, and then 1 year old. But then we have a beer, and let's just say I made my own brand of beer, and that is 11 years old. Notice what we're doing. We have 2 keys, Brian, and we're not overwriting those values. We have 2 different groups. So that's really what it allows us to do, and I'm hoping this is that aha moment, if you haven't had already, is that you can have a group, and the key is specific to that group. From there, we can go ahead and read that back. You can just say 2 heart, get age, and then our settings, our group, our key, and then we get Brian the person, settings, people, Brian, and then Brian the beer, settings, beer, Brian. Notice the 2 different groups, same keys. Let's go ahead and save run. Assuming I didn't fat finger anything when we were writing that code, it should just work. Ta-da! So 2 heart is 1 year old, me as a person, let's say I'm 44, and me as a beer would be 11. It makes it very easy to set things into logical groups. The biggest caveat being if you're going to work with a group, you need to do a begin group, define the name, and then end group to make sure the next time you access that setting, you're not in the wrong group. A question that often comes up is how do you navigate groups? Meaning, what if you don't know what you have? It's actually pretty simple. I've got a lot of code here, and if you're just tuning in, don't get intimidated. This is virtually the same code as I had in the last video. We have save age, where you have a settings, a group, which is, of course, the logical group. You have a name, which is a key, and then a value. And we're going to begin group, set the value, end group, and then, of course, read it back. And we're just going to collapse those just so it's not super confusing. And we already got some things in here. So for example, we have people Brian, 44, beer 2 heart 11, and then beer Brian. Notice 2 different groups, same key. That way you don't have a key collision and they have their own distinct values. All right, now that we're caught up from the last video, this is where the complexity is going to come in here. I'm going to say Q string list, and let's call this people. Notice what we're doing here. We're going to just ram some people into that group. And I'm going to say people. And I'm going to repeat a key just to show what happens. Say Brian, Tammy, Heather, and I'm just making up a name, Chris, my son-in-law. So I guess I really didn't make up a name. Chris is not a figment of my imagination. He's a really good guy. Okay, so we're going to do a for each. I want a Q string person in our people. So all we're really doing is for each Q string in our Q string list. Then I'm going to say int value, and I'm just kind of ramming through this because it's kind of just drudgery here. I'm going to say Q random number generator. We want to get the global, and we want the bounded. All we're doing is we're going to say, I want some random number with a maximum of 100. That's all we're really doing there. And in case you're wondering, I included the Q random number generator and the string list right up here. So we're just getting a random value. Really, it's all we're doing here. Now from here, I'm going to say, save age. Notice what we're doing here. Okay, so we are going to put some random settings in here. We don't really know what we're doing. And I'm going to put this in test under person. And let's go ahead and give it our value. Okay, very scary what's going on there. But basically all we're doing is we're creating a new group using our person, which is a Q string, with the random values. So we're going to have 1, 2, 3, 4 keys with random values attached to it. Now, because I've done some writing, I just want to, make sure things are copacetic in the background. So I'm going to say settings.sync. Remember, we kind of skipped over this in the previous video. I want to actually ensure this writes unsaved changes to the permanent storage. So this is basically the same as saying save. It's just going to synchronize that down to your storage medium. And I'm even going to put right here, save, just in case somebody says, well, how do you manually force it to save? And just in case we want to know where this thing is, let's say file. Now on Windows, this may be funky because it's going to give you some registry setting instead of an actual file name. I should say it may give you a registry setting. Again, the behavior can be a little bit unpredictable at times. That's my only complaint about this class, to be brutally honest. I'm going to say for each. And let's go ahead and dig through this. I want QString group, hope if I spelled QString correctly. Group, not clone work group. Work with me here, keyboard. All right, now that we've gotten through that struggle, say settings dot child groups. Notice how it's not children or groups, it's just child groups. That's one of the things that really kind of messes people up. So I'm going to say settings dot begin group. Yes. And of course, whenever we do a begin group, you guessed it, we should probably do some sort of in group. So I'm going to say settings in group. Don't really need it for this example because every time it loops, it's going to say begin group and it's going to switch. But I just want to make sure that gets drilled into you. So now I'm going to simply say QInfo. The reason why I'm drilling that into you is because I have made the mistake of not ending the group, and then I go to read a key or set a key, and I am in the wrong group, and bad things happen, and I spend half the day trying to figure out what just happened and how to fix it. All right, so there we go. We're going to get our group. Now I want to say for each, just doing another loop in here. And I want to say for each QString key in the settings, and we want the child keys. From here, it is just ridiculously simple. So simple, I'm just going to do the old copy and paste just to save a smidge of time. We're going to say we want the key, print it out, and then settings value key, and then we're going to convert it to string because remember, that's a Q variant. All right, so quick recap before we run here. We've got a few things going on. We are saving people and beer, and then we're adding in some people in a test group. So we're gonna have 3 groups, people, beer, and test. Let's go ahead and see what that looks like. Okay, so here is our file. We have made sure that we have synced this before we try reading from it, just to make sure all of that gets pushed down to the disk. Then we can correctly read back. We have a beer group with 2 people in it, or I should say 2 things in it, Brian and Two Heart. We have a people group with Brian in it. And then we have a test group that has Brian, Chris, Heather, and Tammy. So you notice how you have some key collisions here. Brian, 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 but they're in different groups, so it really doesn't matter. Now, if you try to change Brian in beer, it's going to overwrite this specific key value pair. So you gotta be a little bit careful when working with groups to make sure you're in the right group. You avoid those headaches by always doing an end group whenever you're done working with it. Now, this video, I'm going to show you what I call the quick and dirty way of doing things. And what I mean by that is you're going to see this is how most Qt developers do it. Okay, so what are we doing? We're setting the file name. Why? Because we want complete and total control of where this is. How? We're going to simply add it to our current application directory. You remember the very first video, I opened my application directory and was kind of like mystified as to where the file actually was. And that's because I'm used to doing things the older way, or more to the point, my way, which is I know where that file is. So let's go ahead and look at how to do that. So we're going to say QString, and let's call this file name. We're going to say A dot, in case you're confused where A is, it's actually our Qt Core application. We could also just say Qt Core application and then call it from the static, but I'm going to just say A dot, and I want the application dir path. That is the actual directory the application is running in. And this is pretty typical of most applications. You're going to find your settings file right in there. And I'm going to say /settings dot .ini. And this allows you to actually define what file you're going to work with. And before you ask the question, yes, you can have more than one of these. You can have as many settings files as you want, just name them appropriately. You could call it colors, peoples, game settings, whatever you want, doesn't really matter. So I'm saying QInfo, and let's go ahead and say file name, so we know where this is actually going to be located at. Let's go ahead and save run. Aha, so now we're going to be in home, root shell, code, Qt, and then our obnoxiously long build folder name under settings.ini. And I can actually, that's going to be the file name. It's not going to be in a hidden folder anymore. So now we have complete control over where we put this. We could have, if we wanted to, even ask the user, hey, where do you want to store your settings? Now from here, we're going to say Q settings. And we're just going to construct it. And you notice option 4 out of 6, that may change with time. You can define a file name, a format. So that's exactly what we're going to do. We're going to say, we want this file name, please. Now we're going to define a format. I'm going to say Q settings format. And you notice there's a bunch of different formats. You'll see all these custom. Don't really play around with those unless you know what you're doing. Go right down to INI format. And there's going to be some people probably in the comments that say you shouldn't use INI format, but instead you should go ahead and use native format. There's some subtle differences there. I've always found that INI format, if you bring it up in help, it just says not available. So it gets a little frustrating trying to dig through some of this stuff. I mean, as old as Q settings actually is, you'd think it would just bring it right to it. But anyways, so you have native format, which of course stores the settings using the most appropriate storage format, which of course means it's platform specific. On Windows, that means system registry, Mac OS, da-da-da-da. That's what I mean by some people are going to say you should use native, where we're not doing that. We're doing the INI. And then you can actually define registry 32, registry 64, INI, what we're using, stores the settings in an INI or a flat file. And you can say invalid format and so on and so on. And then you have to define all your formatting, which I'm not going to get into because I highly recommend you don't even try. Let's just stick with what works, which is the INI format. All right. From here, it's just ridiculously simple to work with. I can go ahead and say settings. We're going to go ahead and just begin group. And I'm going to, just for the sake of time here, plop in some code because we already know the API. We're going to begin group, set a value. So people, Brian 46 in group. We're going to sync, meaning whenever we sync, we are saving that file in the background, basically, is what we're doing. I say basically because it really depends on what format you've chosen. If you're working with native and you're in Windows, it's going to do its thing. In Mac, it's going to do its thing. Everything else is going to do something entirely different. And then we're going to go ahead and begin group. Because this example is so simple, you really don't need those two. I'm just putting them in there for demonstration purposes, that when you begin, you should end. So anyways, we're going to go back into our people group. We're going to say Tammy. Now notice we did not set a value for Tammy. So I have our default value, just in case you wanted to see that. We're going to make a Q variant with some sort of, hey, person not found. And then Brian, which we did set. Again, we're going to get that, and we're going to use a default value if it's not found. And then, of course, we're ending our group. Save run. Let's see this thing in action. All right, so here's our obnoxiously long file name. Tammy is going to return a Q variant of person not found. And then Brian is going to be a Q variant of 46. And you can, of course, convert that to a string, an integer, whatever you wanted to do. The point is the Q variant wraps that value. All right, let's go ahead and look at our actual file. I'm going to go in here. And ta-da, now magically our settings.ini is in here. And if we crack this open, it's just an INI format. We have our group, we have our key, we have our value. It's very simple, very easy to read.